Hello everyone, welcome to another stream. How are we all doing? Why am I not in chat only on my phone? This is not good. There we go. Hey Rohan. Oh yeah. So last stream. I love this album, it's so good. Wait. There we go. Yeah, so last stream we got the object pool in, but I want to fix a couple of bugs that I found off stream to do with that first. And then we're going to be integrating these. We're going to be using these custom allocators that we've got, custom growable array, hash table, and the object pool in our code base. So it'll be quite a chill stream today, just sort of converting the code over to using these new things. But yeah. So if I hop over to the Discord, I found a bug last stream. Oh. There we go. So the bug was the object pool can be initialized with more elements than the ID can hold, right? So this is something we should fix for sure, right? So our object pool, you know, let's get the so let's get the Milton up. Oh, not that one. This one. Alright, here we go. So the first problem, actually I don't think I need to draw it. When we have this sort of like ID that we make, right? It's just a 32-bit integer. And when we allocate an element with the object pool, it gives us back an ID. And the ID has 20 bits for the index, right? So what that means is when we allocate our object pool, this capacity has to be limited to those 20 bits. If not, you could theoretically create more elements and it'll be super buggy, right? So we're just gonna fix up that quick. So literally just like debug assert that cap is less than or equal to one shift left. Actually no, there's no one shift left about it. It's just the ID mask. And what we're basically saying here is that the capacity for the object pool is larger than the number of bits. Okay, is larger than the number of bits in the ID. Larger than what number of bits in the ID can hold, or something like that. There we go. And then the other bug, so that'll fix that one right there, which would be super cool. So the other bug that I thought about off stream is that the object pool bump allocates its elements if the free list is empty, right? So the free list only gets populated when you actually free something back to the object pool. But when you haven't allocated, so say you got your object pool allocation, right? You've got this many elements in it or whatever, and nothing's allocated. So you say, okay, I want to allocate something. So the count is here, and the capacity is up here, right? So you just go, okay, allocate this guy. So I'm going to then advance my count to here, right? Allocate this guy. So then I'm going to allocate, and then it allocates it where the count is and advances it, right? Then allocate another one, allocates it where the count is, and then advances it, yeah? What happens if I decide to free this element here? So then what happens is it decrements the count back by 1, right, back to here. And then if I were to allocate, is that right? Wait, maybe it's fine because the free is empty. The free list would be empty. Actually, no, yeah, maybe it is safe because you have to exhaust the free list, meaning there'll be no holes, so you can use the count and extend it. Ah, there's actually no bug then. That's good. Yeah, because you'll allocate this element again before you advance the count. Yeah, excellent. That's good. I'm happy about that. Awesome. So yeah, I think that's the only thing I had to fix. Legendary. Cool. So, right. So what we're going to be doing in today's stream is effectively going throughout the code base. We're just going to start off doing this at least, and move, like we just have like 32 elements, you see, of things, because I didn't want to use malloc and allocate any memory, and just like I was waiting to get these custom collections in as well. So now we're going to be using these new custom collections. They're going to be using like this. We use like the core stack, whereas this we use the core object pool, right? We also need to probably have our custom allocators set up as well. So I was thinking, I don't know actually what I was thinking about those. We probably want like a static allocator, and then probably have one for runtime that gets cleared every frame, you know? Yeah. So it's just, where are those going to live? Are they going to live? They might. It must be part of the game, maybe. Hey there, Sandro. How you doing? How's things going? Oh, my days. So tired. I stayed up so late last night. Hmm. Too much drinking as well, you know. But yeah, doing good. So is that too much sugar? No, this one's sugar free. This one's the zero sugar one. Oh my days, I knocked the cable again. Okay, I'm forcing myself to finish at least something I've started. Excellent. Yeah, very hard thing to do. Working through WebP things. Finally to build and encode sprite sheets with C99. Oh yeah. Gonna build a GUI now. Cool. What sort of GUI are you building? Retain mode, immediate mode. But yeah, nice doing some WebP stuff. I've not used WebP yet. Use a straw. Nah. Yeah, but artificial sweetener is also not good either. Yeah, I heard about that. But yeah. Tomorrow starts a week of the old computing challenge. 1 week, 512 megabyte, 1 gigahertz, single core for everything. Oh. Good luck with that. You know, you have to be using old software as well, right? Old hardware and old software? Type of thing. So where do my linear allocators want to live, right? Should I have them in a header file? which is accessible in all of the subsystems. Because right now we don't have anything like that. We have core, obviously. That is something like that, right? But I want something that's to do with the game that maybe houses everything. And like, because obviously when we introduce multiple threads, this is gonna change, right? We're not gonna have an allocator that sort of like gets used across multiple threads. You have it local to a thread. Um, so like uh we could do thread local storage. And thread local storage on something is okay from what I've heard. Maybe we just do thread local storage and keep our custom allocator in there. Maybe. Hmm. Yeah, I think with thread local storage, if it's in a DLL, there's a bit of a performance penalty. But if it's static, if it can be known at compile time, uh, you don't take too much of a performance hit. So maybe it's a good idea to do thread local storage. Have a think about that. Yes, but I use terminal crap for almost everything anyway. Okay. Oh yeah, that's cool. Firefox with modern web JS bloat is the main issue. Yeah. Yeah, like if you want to use the web, yeah, you gotta get a good machine, or just use your phone, right? Um, but yeah, I'm thinking like we could just have a single global that's just shared everywhere, but then like when we boot up the when we want to take it into like a multi-core environment, the way we'll probably share stuff around everywhere is just have a thread local storage context that has like a big structure that's shared everywhere. So maybe we do that. So you have your thread specific allocators in there. Yeah, maybe we'll give that a go. Should we try that? So basically, like, you want a header that knows about everything. Uh, is that right? And yeah, and I think we'll do a game.h or something like that, right? So let's create a new text file. We could just call it game and have a game thing. But let's just say like game.h, right? Let's give that a go for now. So do the pragma onces. Hey there, Egotist, how you doing? What C99 GUI library would you use? I thought about nuclear or MGUI. Maybe GTK. Um, yeah, I typically just write my own, basically. Um, but yeah, like if you want to use something nuclear, I guess, um, does the job. Um, it depends really. Yeah, I typically just do my own, but MGUI is really good, but it's not really C99 though, whereas nuclear is. You have to use like a wrapper for MGUI. But yeah. I'm doing alright. How's things going you? Yeah, not too bad. I drank quite a lot of alcohol last night, so I'm a bit tired. I got like 5 hours sleep. Um, but yeah, doing good. My wife's had a baby shower, so we got tons of gifts, tons of nappies, tons of clothes for the baby. So we've got so many good gifts now, which is really cool. So super happy about that, you know. So I think we'll just make like a game structure in here. I'm not sure we're gonna stick in it, to be honest. But yeah, let's just do like float placeholder. And then like we'll do another one. And this would be like game TLS, thread local storage, yeah? Now, what I want to stick in here is the allocators, right? So I want like one of those core linear allocator. So I want like a static allocator. Static allocator. I also want like a sort of per frame allocator, right? Well, frame is not really a good word, but maybe it is. Maybe it's fine. So here we'll include the cores, right? And then this way we can just be like, right, thread local, okay, G TLS or whatever, game TLS, something like that, yeah. Let's have a game structure. So I think this should be a little bit future proof. I hope, fingers crossed. I've got to get some thread local storages at the ready. Thread local. Something like that. Oh yeah. So we kind of want to like instantiate this. Like we want to have a way to instantiate the game TLS per thread. So we need like a way, a little function to say like, well, void game TLS in it. And if you were to initialize this thing, you kind of want to have like, you know, yeah, or maybe we can just boot up the whole game on a single thread, and then we just have a frame allocator per thread or something. Maybe we'll see. Hmm. Maybe we have the static allocator. No. Because you'll have different threads. Yeah. So I think you initialize it, and you kind of wanna have like some form of like TLS. What have we called these in the past? Have we not got any of these? Yeah. Okay, we haven't. Right. So I want like some form of setup structure, you know? Or what do I call it that? Or like a spec or something. And we should really do this, right? TLS. Any hopes that Linus would upgrade the kernel from C89 to 99? Oh, no idea. I didn't realize they're on 89. But yeah, C99's got some good stuff. Good stuff. Yeah, they're going straight into Rust, yeah. Are they using C11? Wouldn't TLS be for transport layer security? Well, TLS is known for thread local storage as well. But yeah. I could just call it G thread local, right? But yeah. We'll see. Hey there, Ansel, how you doing? So I think we might have one of these specs or whatever. And you'd just say, right, uPointer static allocator size, and you'll have like a frame allocator size, and you can just like instantiate this, right? So I think that'll be pretty decent. Cool. So now we want to go into like game.c, and then we can like take these, drop them in here, include the super lovely game.h, and then I think this will be what we want. So now we can just say like, right, core linear, wait, do we have a core? Initialize, excellent. Cool, then we say spec, static, no, spec, G game TLS, static allocator, spec, static allocator size, bam. And then we do the same thing for that frame allocator size. There we go. So now we've got some custom allocators initialized. So they're just basically 2 blocks of memory. One is used for instantiating the whole program with, and the other one is gets reset every frame, and we just run over the same memory again at the beginning of each frame. So I think this should do for now, and we can use this basically everywhere. So we just want to sort of instantiate this, since we only really have one thread at the moment anyway in our main. So in our game main, we're just gonna, probably after we boot up the operating system, we want to then initialize this TLS thing, right? So let's just get these oh, they're using C11, excellent. What's TLS? Thread local storage. So we're just gonna say so let's be generous and do the 8 megabytes. Right? Do we have like a core megabyte or whatever it was? Something like that. 8. Yeah, I think we'll do one of those. Then we have this sort of frame size. Let's just do 8 megs again. We also need to include the game.h here, and probably the game.c as well. Then we're just going to pass in that super lovely spec, initialize that. So now throughout the whole application, we can just use this thread local storage thing. It's a global that we can have access to. And if we have multiple threads, this will hopefully just slot in right to the future design. Right. So now we've got this. We probably want a nice little way to get the allocator, right? So we're just going to do like probably something like static inline, right? Game TLS static allocator, and then like what I want to do is obviously return the core allocator interface, and we are essentially just going to take void in, right, nothing. And what we're going to do is we're going to return a core linear allocator, right? Oh no, oh yeah, so G, so we need an address to the linear allocator that we want. Then that will turn it to an allocator interface. So remember that from when we did our custom allocator thing. It's basically like, so we have like a pointer to the allocator instance, so a pointer to this is just a void pointer, so it's typeless. And then we have an allocator function, which basically allows us to allocate or deallocate from it, depending on how it's used. So here's the allocator function prototype. If this is null, then it's an allocation. If it's not null, it's a deallocation, right, of size and a line. And there's the instance pointer to the allocator instance, and in this case, it's the linear allocator. So we have an allocator function here, takes in the linear allocator, and the allocated point are in size and align. So when we do this, we're essentially just saying, right, give us an instance pointer to this structure, put that in there, and then we'll cast that into the correct function pointer type. So we have a sort of an interface that can get called in any system, any collection to allocate memory, and it doesn't matter what allocator it comes from. It can come from this very basic allocator or a more complicated one. So we're just creating those basically. Also, I thought raw kernel is C only and modules for Rust. Yeah, I was thinking the same thing, right? Is that right? So where's game C? Not game C. Oh yeah, this is it. So now I just want to make sure I do the other one for the frame allocator as well. So now from anywhere, we can just call these functions and they get the allocator that we want. No biggie, right? So this is what we're going to be using. So let's go to the GPU system, and let's begin. Let's replace all these to-dos and use proper dynamic, like these proper collection types. So this is our GPU internal API. So it's the stuff that sits behind the public API, and it just forward declares everything, so we can put comments in here and not have it loose in some C file, right? It just gives a zoomed out perspective of what's going on under the hood. So, you know, we have our resource here, which could either be a buffer or a texture. And then we also have this readback API. So this to do make a blah, 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 blah. Yeah, we need that. Right, so what is that? Does the queues need to be... Yeah, we've got to look into that, because we have this sort of readback queue. Auto copy queue, interesting. Think about that. Is there a way to make a readback queue? There's a count there. Interesting. Wait, I'm not in the public API, am I? So I'm obviously not going to find the create function for it. Right, here we go. So you can actually create a readback queue. Okay. So it's a way to group your readbacks together. Interesting. So I think here, this will probably use the pool, right? The custom pool thing. That'll be great. Okay, so when you you say Q initialize, or whatever it is. We don't have a de-initialize queue, but that's fine. So this one is when you have these readback buffers. There's basically two of those, and so it's... Yeah, I see what we're doing. So we probably just want to instantiate the... Right, I have an idea. So I think calling an ID is a bad idea. Instead, we'll call it like enum, and we'll just say that you have to tell us how many you want up front of these, and we'll just dynamically allocate this array. Right, so there you go. We'll sort that out in a bit. This one is definitely one of those super lovely growable arrays that we've got, so we can just do this. Basically, we will have to define ourselves so core define stack, like that. So it defines as a custom stack type of this auto copy entry. That can go right, so that'd be really cool. Let's do something like that, yeah. There we go. Yeah, true. Kernel core is the only. That's good. Good. Right. So auto copy. Okay. So I think what we want to do is say like enum GPU read back Q auto copy. Is that internal? Yeah, it is internal, isn't it? So basically with the readback stuff, we can read back from a resource. And there's two different APIs. There's an auto copy API. And there's so it automatically copies it to a destination pointer for you. And whereas this one is more like you get to read it directly from the GPU resource at a certain window in time. Basically. So yeah, I think this is more internal. Yes, I guess we'll make it constant. And what would the idea on how you're planning to use the collections you've made? Sure. So, well, whiteboard, I'm not sure. Yeah, so right now, throughout the whole code base, we've just got arrays of like 32 elements sticking somewhere. And we just need to go over and sort of like turn them into either like a growable array or an object pool. And that's the basic idea. So we don't have any custom allocate. There's only one place we've done allocation, or that one malloc, and I need to replace that as well. But yeah, so we'll be going through the GPU internal system to start off with, then go into the Vulkan backend because there's some allocations in there, and to get them to use some proper growable arrays and stuff like that. But I don't think there's actually too many. I think it could be quite smooth sailing, to be fair. But yeah. So I think this, when we do this sort of define auto copy thing, I think we can give it a -1, basically, or a U32 max or whatever it will be. So what I want to do, we could just say -1. Yeah, so what I want to do is I want to get rid of this Q thing. And instead we're going to have like this Q enum. So it's to do S32 equal like GPU read back Q enum, we'll call it. And this is what we'll be using instead. So just be called like Q enum. GPU read back Q enum. That way. GPU C. Oh, that needs to go. Just quickly shoot over these though. Okay. So get a Q. You do have a Q enum. So that's internal. So when we instantiate this GPU backend, we need to say how many readback queues we want, basically. Shouldn't be too difficult. So that can go. Right, so non-zero, we kind of want to just say like, yeah. What? Q enum. So I think though, if it's equal to -1 or something, that special readback one, might have to do something. Oh my days. Different signs? Okay. You know what? Let's make the CU32 max. Alright. So right. So this is when we sort of do a readback and we tell it to like automatically copy. We go into the readback buffer and we sort of queue a little auto copy entry. So here we get to use our new API now, right? So we get to say core stack, right? Push, and we just say push onto there, right? Just need to take the address here. No need to increment the pointer anymore because that's part of the whole push function, right? Gives us back a nice pointer, and there we go. So that's how, like, I'm really happy with how the API came out with this stack stuff. It's just really good. And then same with that one. Cool. Right, anything else that's sticking out? Auto copy entries count. At the frame start, you want to clear it? Sure. So this would be core stack. Do we have a clear? We don't have a clear yet. Okay, so we'll make that one. So clear is basically resize 0, I think. Yeah. So here's our core stack. I just think we could probably add. Yeah, it might be nice just to add like a clear, which just takes in the stack and just calls resize with a 0 in there, right? That would be pretty good. So we'll do that. So just going to say at the start of a frame, can you clear the readback auto copy entries for me? Take the address and voila. This one is trying to access the element, which is going to fail. So we need to use the core stack get thing here, like that. Yeah, so this would do like a bounds check in debug builds, and then in release builds it would just compile out. So that'd be good. Do I use Arch? Kind of. I use Manjaro, so it's Arch based. But yeah, it comes all pre-set up, and they do some good things. I have done many Arch installs, but yeah, I just got bored of doing it. So Manjaro is a really good fit. Right, so we've got no problems now apparently in the whole GPU.c file. Although the number that we should be looking for, that sort of like count. Where is it? This one, read back queues count. We're not setting that something sensible anymore. We're just using it, I think. Right, set to 1, 0 is the auto copy. Right. So what we want to do is we kind of want to say like there's like an enum. You know what? This is an API specific for this game. So I'm just gonna stick it. Like, is it good just to stick it in here? So we could just say enum readback queue. Have them all encoded in there. It's a bit of a leaky abstraction though. Yeah, let's have it past him. So what we should really do, should have had this for a while now, is we should really pass in some state, right? So pass in some GPU spec, and this helps us like instantiate the GPU subsystem. And obviously run it specific for this game and everything, and it could just be all hard coded as it goes through. But you know, if I want to pick this up and take it to another project, maybe it's just good if it had something like this sometimes. I don't know. So we always want a number of queues, right? So U32, number of readback queues, please, and we'll just use that number to basically say, okay, that plus 1. Bearing in mind, index. Okay, the last index is the autocopy queue. Spec in hash table. What do you mean by spec in hash table? I'd rather use serialize spec. In hash table format. I'm not sure what you mean. And then load it back from disk at runtime. Right. So what you're saying is like you'd rather put the spec in a hash table for some reason. Okay, and then it'll be serialized on disk that you load up at runtime. I don't know what benefit that would bring. I think we're just gonna sort of instantiate these at runtime through code. It'll be code driven, right? Not so much data driven. But yeah, I guess it depends on the code base, right? Maybe you do want to have these things configurable in some config file somewhere, right? Some of these little options. But yeah, I don't know if we need that at all. So, it sounds decent for some problems though. But yeah, I see what you're saying. Yeah, so sort that out. So now I've got these counts and everything. What is this doing? If it's not been recorded. I see. Yeah, makes sense. Yeah, I think if we end up doing something like that, we'll just do it. But yeah, not until we need it. Yeah, so if they're passing in a Q enum, you need to do whatever -1 because we add one, right? No, because this is an internal function. So what we're really banking on is like when you call this, right? Your Q enum actually needs to be one less. So we need to say debug assert that this is less than that -1, and what you're saying is like Q enum out of bounds, right? Something like that. And you want that on the readback buffer, readback texture, readback. Everything that takes this Q in, right? What else? Readback start and nope. Q read. What is a Q read? Yes, this is the auto copy queue, you see. Which is kind of like a built-in private thing. Because we do it. We read over the queue at the perfect time and do the mem copy for you. Right. So if you pass in an enum here, command read, command read. Yeah, so I think we just need an extra one of these functions then if we're going to redo the debugging thing properly. So as if we need like an internal one, right? And then more of like, so if we want the internal readback stuff, resource readback, right? So we need to put one there with an underscore on it, so it doesn't do the check. Well, it does a slightly different check. So we basically want like this one. So this one's going to call this one and just return. But then it's going to do that check that we saw up here. And then this one's going to do the check without the -1 because it can be used for the internal auto copy queue stuff, basically. There we go. So at the start of a frame, like this is when you can do the readback stuff. So we basically inject this auto copy queue to sort of like go over all of the readbacks that are going to get copied to some more permanent or longer lived lifetime area, and just mem copy it to there for you, that you having to write your own special readback queue basically. It's quite handy. Pretty good. Right, so I'm glad that's sorted out. That's made it a lot better. Let's double check and make sure we tackled. Right, see if we've got any more. So when this queues thing, right, we didn't actually allocate any memory, did we, with this? And then with the auto copy entries, we also didn't actually allocate the memory for this, did we? Right. So we've made the API better now, but we've just not handled. Oh yeah, and when we do a get for this auto copy thing, we need to like get last basically instead. So yes, what we need to do is say if blah is equal to that. What we want to say is like your QE num is now going to be equal to ggpu read back queues -1, right? The last element, right? Okay, so that's fixed. So when we instantiate the whole GPU system, what we need to do is we need to actually go over. So we need to do one of those super lovely for ranges. Get the active frame index, right? From 0 to GPU active frame index count. So this is the number of frames that are running at one time. So there's two, right? One that the GPU is reading, while the other one is being prepared, or the next frame is being prepared by the CPU to run on the GPU, right? So we actually double buffer the readback buffers because again, the GPU is writing to one of the readback buffers while the CPU is reading from the previous frames one, right? So we just go, oftentimes we'll do this so we can sort of, it just iterate twice and then just fill in the data there. So we just want to allocate, we want to get these readback buffer things, right? Not for those. No, yeah, we've got readback command buffers as well. These are, so the readback command buffers, if people weren't there for the stream when we did them, they're effectively a way for the GPU to do some logic and output commands that the CPU then reads back and does some actions. We haven't got any specific use case for it yet, but it's a bit of fun, and I'm hoping we can find some use case for it. Right. So we're looking for this active frame index, bam. And then we need to use our new super lovely initialize stack for me, please. Oh, what's that? Yeah. Address of readback buffer auto copy entries. So this is just an array of pointers that we're going to be copying back to. And then we're simply just going to pass in the allocator. So the allocator we're going to pass in. So we need to basically get the core I allocator static allocator. And that's just going to be equal to game TLS static allocator. Right, so there's that function. We get to use it now. And then simply, so we just need to include the game.h. And then simply we can just pass in the static allocator. And then how big does it need to be? I don't know, how big does it need to be? That's a good question. So we've got these readback auto copy entries. So I guess that's another thing that we can pass in. So how many per frame, basically? So it's like, yeah, I don't know. So spec this, done. Okay, so that would instantiate the stack. Now we just need to instantiate the queues. So that would just be a growable array. So one thing that we did when we did our custom allocator stuff, right, is we made it really nice, just nice convenience macros to use this allocator interface just to allocate a size and a size of a number of bytes with some alignment. Now, what we haven't done is made it really nice to allocate elements, right? Or allocate wait a minute. So size of t and then a line of t. And also allocate arrays, right? Because sometimes you just want like an array of elements. It's kind of a lot of those, and it's nice to have these convenience functions around, right? Times count. And then obviously you want to do the opposite, where you can deallocate it. So this just calls the allocator interface, and it's just going to pass in an allocator pointer here to indicate that you want to deallocate, right? And there you go. So yeah, that's super handy. So now what we can do is, so remember here we just want like an array of queues, and we have like a queue enum. So all we need to do is just say rb queues equals core. Wait a minute, I did a silly thing. I need to cast this. T star. There we go. Then it's type safe. So we want allocate array. The element type is going to be this one here. And then the number of elements is obviously the number we made up above earlier, this readback queues count, which is kind of passed in from the user. But we add one for an internal queue, like that. Wait a minute. Oh yeah, we need the custom allocator. So it's static allocator. Okay, so that's really cool. So, right. That was kind of a weird one to start off with, but yeah. So this is the basic idea, right? We're going to be allocating this memory now using the static allocator. So currently we've got 8 megabytes, right? We have like a static allocator which has like 8 megabytes allocated from the system, and then we're just going to subdivide this as and when we need it. So we're going through the GPU system right now, and right now at the start it's just going to basically allocate this thing, which maybe say is like, I don't know, 100 megabytes or whatever it is. I don't know, probably less than that, probably far less than that. Allocates this one like this, and then for the queues it's going to ask for another, like, I don't know, meg 1k or whatever, I don't know. And it's just literally going to bump allocate it, put it here. So the issue with this obviously is like if you go out of bounds, you just overwrite the memory next to it. But it's proper efficient in terms of they just slot right next to each other. It's really easy to allocate because it's just incrementing a number. So our pointer is currently here, and when we do our next allocation, it will return this pointer back to the user, and then we just go, okay, well, this needs to be this big, block it off, and then allocate this memory, and the pointer will go there. So we have a static allocator, and we're just going to hopefully fill this whole thing up. If we don't, we just resize it to like a good size for our game. So maybe our game only uses like 6 meg when it launches up or something. You can just like take it down from 8 meg and just leave it at 6. But yeah, just pre-allocate the memory, be super, super sweet. Right, what's the next thing we need to do? So we've got some more collections to sort out. So that was the readback stuff, but now we've got it in the actual core GPU API. So there's a few, right? There's this resources pool. So that's going to be our object pool, the one that we made last stream. So we're going to be definitely sorting that one out. This one's a dynamic array. It's a bunch of sync states for the sync code. This one is some more next command sync resources. Yeah, this is more synchronization stuff. And then yeah, so let's get these going, right? So when you have a resource, we basically want to have a resource ID. So that, okay, I know where that one is. Excellent. So we're going to do our whole core define object pool. So the object pool is a pool of resource objects, and you access them with a resource ID, like so. And so now we have this type, this object pool type that we can use. So we're going to go back to where we were, down here. And we'll be able to say now core object pool of GPU resource. And here's our resources pool. And there we go. Excuse me. So now we can just use this. So let's plug this in. So it needs to be instantiated, right? So here we have this sort of like next ID. It's sort of like, it's always built-in IDs and everything. Do we even use this much? Oh, we do. Okay. That makes sense. Right. This is going to be good. So basically, like, the game, again, they'll be like, what's the number of resources that the game wants, right? That gets passed in. And all we're going to be doing is using that core object pool. We're going to initialize. We're going to take the address of GPU resources pool. And then we're going to pass in that spec. No. Wait a minute. The static allocator needs to come up. So we need to know where we're going to allocate the memory from. So just use that static allocator, right? Bump a range of memory that we need, and use that. And then we're going to be using the resources capacity from. Bam. Use the resources capacity that gets passed into the function, and then allocate enough, like an array that's large enough for this object pool. Cool. And then we've got a bunch of like built-in resource indices. These are, for the surface, so for the display surface, an upload buffer, a readback buffer, a readback command buffer, a debug command buffer to read back, and then a printf buffer as well for our shaders, right? So yeah, we want to make sure those things get IDs. So this used to allocate those because it's very temperamental, but now we're going to be using the new thing. And the new thing is core object pool alloc, and then we're going to allocate this one. So we're going to pass in GPU resource pool, and we want to say where it goes. So I think you pass in this. Yeah. Cool. So that's going to allocate, it's going to go over each of those enums, allocate a new object for those. We're not going to do anything with it, but we could potentially in the future. But yeah, we'll see about that. But yeah, it just allocates them basically, those built-in ones. So that next resource ID was the old way we used to allocate, but it goes away now. This, right, here we go. Core object pool. Get. We're going to get using the resources pool. Then we're going to use the built-in ID. Really, we can actually use the GPU surface res ID. Excellent. So this will get us our resource ID for the surface, which is in this built-in array basically. Yeah, so just indexes that, you see. And then we'll use that ID to index into the pool and get ourselves the surface resource pointer. And then we'll just properly initialize it, you know, like that. Cool. Yeah, so I guess let's have a little bit of a scan around and just make sure it's all good. So when we instantiate a buffer, oh, interesting. We need that allocate function again. So here at the top, when we instantiate a buffer, we basically want to have our res ID here. And then we want our GPU resource pointer like that. So res ID goes here. So we get our ID, which the user will be using and holding on to. It's 32 bits of information. And then I got this function here. I could use that one. It's shorthand. That'd be way better. Let's take this. GPU resource get. Much cleaner. There we go. So now it just uses this, and you pass in the res ID. Oh yeah. So, so when we initialize our texture, we also want the same sort of thing here to use that. Right, see if there's anything else. So that's calls into the backend. So the backend still got some bits to sort out too. This one gets you the ID from a pointer. When have I needed that? I haven't used that yet, but it could be handy. So in our core side of things, right? For our object pool, we can quite easily make a function for that, I reckon. Like you basically want you want to take in a typed pointer and get back a typed ID. So really you're saying like get ID. So you go U32 get ID void star, right? Pointer. So ideally with the get, you see, you should be able to do return ID, right? T star pointer. But then you got to wrap it in that ID type, so it'd be like a core ID. Yeah, something like that. So this would be super handy if we just have a pointer, we want to get the ID back. Right, so if I shoot into the core code, yeah, it shouldn't be too difficult to achieve this, right? Like we effectively just want to make sure the thing's initialized. The pointer resides with inside the object pool. So you got entries is less than or equal to pointer and core pointer add object pool entries is plus the object pool capacity, right? And the pointer is less than that, right? Something like that. Pointer is out of bounds of the object pool, or is outside. Pointer is outside the object pool. So now that you've done that, what you need to do is you need to fetch the is allocated. Well, you need to make sure it's allocated first, right? So how would you handle memory waste with the static allocator, or do you have plans to reclaim it back at runtime? Yes, good question. I'm scared of the camera today. What? Hey Perry, how you doing? So with a static allocator, the whole idea is there won't be any waste. You only allocate when you start, like it's for stuff when you start up the application. That doesn't change throughout the whole lifetime of the. That doesn't change for the whole lifetime of the application. So when we build up the game, we're going to have some fixed allocated arrays and pools, and they are not going to change. And that's where the static allocator comes in and shines. Oh, I'll send it myself. I will do. I'll do that, Perry. Yeah, I was just comfortable where I was, slouching over, doing the old slouch. But yeah, thank you. Appreciate it. It's the lilac. Hope you like the lilac. Yeah, so when we build the application, we'll just like initialize this memory, hopefully fill it all up, and then like never allocate any more from this allocation. That'll be the plan. And if we need to do any runtime stuff, we'll probably have a different one that is for the lifetime of a frame, right? I hope that made sense. So when we deallocate, there's a good place for it. Yeah, how's it going? How's it going, Perry? You've been up to much? What have you been up to? So if the bit, we're going to make sure that this bit is set. So we need to work out the index, right? So the index is, excuse me. The index is a good old pointer difference. It's this, right? Between pointer, entries, and divide by entry size. Bam. Gets you index attempting to get the ID of a point of an object pool entry that is not allocated. Bam. Then the next thing we want to do is actually give you back the ID. So we need to get the yes, if we will debug assertions, we need to get the generation, right? Then stuff those bits in the index, and then we'll give you back the index, which is the ID, right? So I think that's right. Yeah, that's it. So yeah, I usually add that function, but I'm glad we got it in, because we missed it. Right, so we sorted out the object pool. All right, yeah, so now we can use get ID. And this gets you an ID from a pointer. Ta-da! Legendary. That's far better now. Right, anything else that appears wrong? Right, there's no errors in this file apparently. Nah, not really been. It's already been bun around like normal. Excellent. Cool. Yeah, it was good. I got drunk yesterday, Perry. I'm now dealing with the with the results of 5 hours sleep. I was actually like in church, like nodding off nearly. It was really bad. But yeah, and then came back and got a Subway. That was good. That's Subway. But yeah, I had a baby shower yesterday. So got tons of gifts, t-shirt or clothes, nappies, all sorts for the baby. So ultimately prepared. We've got like little tiny shoes as well for the baby, like 3 pairs of tiny shoes. So he's got more shoes than me now, Perry. Oh, we have done a bit of a bugger up apparently. That one. Excellent. Right, so now we can go into the back end, I guess. No. Is that a good idea? I think we've still got stuff to finish up in the intern. Yeah, we'll get into the back end side of things. So we've done the object pool now for the resources. Let's hook up this sync state. So the sync state just basically keeps track of like how was this thing previously accessed? Was it read only, read write, write only, right? You know, read or read write, basically. You know, this sort of stuff. What state was it in before, and what state is it going to be in? And do we need to put some synchronization down? So you have one of these per resource. So basically, it's just one of those super nice stacks, right? Stack like that. Well, no. Just an array. It's the same size as the pool, basically. Then this is a stack. Core stack. And that. So when we have this, we really need to define a core stack of that. So core define stack. There we go. Then we also need, so that'd be super nice. And this upload entries. And then, is it illegal in your country to know the gender of PS? Yeah. You basically find out when you go for a scan, right? Yeah, it's quite easy to tell, really. So we found out like on the first scan, but then we kind of found out on the first scan, then on the second scan it was just like blatantly obvious, you know. So we have a boy, you know. Excellent. Right, so we just got to allocate the memories for those now, and then those should all be wired in, hopefully. So yeah. So the first one is this sync states. So the sync states is going to be one of those. Wait a minute. GGPUs dot resource sync states. Then we just need to say core allocate me an array, right, of this element here, the sync state element. I want to use the static allocator. I want to use, I want to use allocate the resources capacity of those, basically. So we just use the index of the resource ID, and we'll just index into there, which would be super nice. Oh yeah, we have to make sure we get that right, because we could easily go out of bounds. We've got to find that. Yeah, we'll go and look for those now. So, oh my days. No, okay, let's do all the allocations quick, then we'll hunt around for the to-dos in this file. The next one is this next command, blah, 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 entries. I'm just going to over-allocate this. Yeah. Core stack initialize, take the address, pass in the static allocator, spec resources cap. Just waste some memory. And then the other one is the upload entries. We kind of want to decide how many, like, actually we have a spec. Let's just pass in some good numbers, So what's the maximum number of resources used per max resources used per dispatch? What's the maximum number of wait, what's the other one we wanted? Uploads. Max uploads per frame. So the other one is that max read back auto copy. Something like that, I think, yeah. Yeah, I didn't know if that was illegal too. I'm not sure. I don't know if it is illegal, right? But it could be. Oh, in India it is illegal just because a very small section of the population don't want to go, right? Yeah, that makes sense now. It's really sad when it becomes that way, right? So this one will be max resources per dispatch. This one would be, yeah, then you want uploads per frame. So for the upload entries, max upload per frame. Then this auto copy one is like max read back auto copy per frame. Excellent. So obviously need to fill those in correctly and everything. The spec incorrectly, but right, that's good. So let's go through here, chase down the to-do labels because they're all to do with like this object pool thing. So dinit to deinitialize an object, like put it back. Like we've got a function for that now. It's really nice. Why does it return an ID? And also, why do you we could just, or we have to call into the back end as well and write the back end code for it. I can't be bothered. Next one, to do. Aha, this is the function. So you want to get the resource ID's index, right? So remember the first 20 bits is where the index is stored. So really, maybe we should write a good function for this. Well, no, you just got the mask, isn't it? So you just use the mask. So you just say like return res_id.raw and it with the mask, and then that'll get you your thing, your index. Right, so as long as we're using that in places, it should all be fine. So this one is saying 0 all of the elements in the sync states. So for this one, you basically have the capacity of the object pool. So resources pool dot capacity, and yeah, you're gonna 0 the whole thing. Maybe that's not good, but yeah. Because we could just store the synchronization state inside the resource itself. But no, but then you still have to 0 it. Yeah, maybe this is easier. Right, so I think that's in a good place. Wait, when did I grow a beard? What? Oh, yeah. When I chose to use Arch and C, yeah, it just blossoms. It's part of the workflow, you know. But yeah. I know I always let my hair grow out a bit and grow my beard at the same time, and then I just get it all sort of like taken pretty far down, you know. That's the way I usually roll. All right, so we're doing a good job right now. We're nearly there with the. Now we're going to go to the Vulkan backend. We're going to find all the uses of dynamic allocations. Probably not many. Or any really. And yeah, fix those up. But yeah, if anyone's got any questions about the project so far, anything they want me to sort of explain, feel free to ask away, because yeah, it's a bit of a chill stream today. We're just patching in these new collections, and yeah, maybe it's a good time to have some other topics going at the same time. This really shouldn't matter, but it does. The C has such a nice. Oh, but to me it does. C really does have a really nice aesthetic. Yeah, I like yeah, I like how simple the code can look. Whenever I see other people's code, they sometimes do like, well, a lot of the time do a better job than me. My code tends to be quite wide. But yeah, typically though you can really just make things very elegant and simple, you know, in C. I like it. Hey there, Glass. How you doing? I've shaved my head and get my beard trimmed. Saved me £11 a month on a haircut. I know. Haircuts are like, wait, that's a cheap haircut. Where'd you go for £11? For me, they're like down here where I'm. They're like 15 quid. Yes, I've seen your. That's amazing. When I got shown that by Perry, I was like, this is amazing. And then I was also like, does Glass know about this? That's great. Right, I see. Yeah. Oh, haircut's expensive. In the new section of Don's Discord. I need to join Don's Discord again. I'm glad he's got one back. I need to come. Right, I'm gonna swing by and get another Coke because I am tired. Too much drinking, Glass, you know what I mean? Too much drinking. Oh no, am I gonna Oh, please no. Close your eyes, people. Oh no, this is fine. Excellent. Nice double chin going on there. I like the beard. uh, Excellent. Oh, close the wrong one. Have you done any research on allocator profile for games? What strategy is good for game EGS polymorphic, linear, etc. Hmm. I know entirely depends, right? Like, yeah, I haven't done too much research on like it just entirely depends on just like whatever your data looks like and how long it lives, right? The lifetime and what it looks like and you know where the data access patterns, right? Like, so you really should just yeah. I think it's best just to think for exactly what your problem is and try and solve it each time, you know. But yeah, I haven't done anything. Yeah, when you say EGS, do you mean like entity component system, or is that, or you mean examples, polymorphic, linear, etc.? Maybe, maybe that's what you're saying. Uh, this is my latest creation. There's also 7 of those in Discord accumulated over the last 7 months. Excellent. Question: is it immature for me to eat a chocolate bar quickly while letting my girlfriend have a piece? After my girlfriend had a piece, and turns out she liked it, and so I ate it quickly so she wouldn't steal anymore. Hmm. I don't know if it's a good move because the thing is that when you eat chocolate quickly, you could have enjoyed it more if you just took it slower. You know, like if you take a small piece of chocolate and you let it like melt in your mouth, it lasts longer and like the taste is, and also goes all over your teeth and destroys your teeth, but it tastes good. But yeah. Double chin equals all good mac and cheese. Oh yeah. Not gonna lie, doing that double chin hurts like crap. On the back of your neck? I thought it hurt more down here. Hmm. Maybe I can feel it. Oh. I remember when uh I remember when I was watching some of Don streams back in the day, he used to do it all the time. A double chin. And he developed some form of like pain somewhere. I don't quite sure where it was. Maybe it was like a neck cramp here. I'm not sure. But yeah, not good. Uh, nah, you enjoy it more as well. Right, I'm just gonna get another Coke. I'll be back, and then we can resume on this GPVK stuff and get it all up and running again. Right, BRB. Enjoy the tunage. Oh, ho, ho, welcome back. Oh yeah. Right. So let's hop in the back end. We're just gonna. I forgot why we need to go back in here. Yeah, it's because that's it. Yeah, the resources pool used to just be literally just like a pointer to a bunch of GPU resources, but now it's this object pool. So what we need to do is basically get the object. Easy peasy. GPU resource get, GPU surface resource ID, bam. So we just need to do that for like all of these guys. And I don't know how many of these we got. Is this for the upload buffer? Upload res ID. Oh, come on. Right, upload buffer res ID. Gotcha. Read back buffer res ID, I'm pretty sure. Yep. Did we delete those from the public API? Are these only internal now? I don't know what's going on. So, you never want to access these directly. Like, these are internal. Except for the surface one. So, I think what will be decent is one, we need to finish these off. We've got to read back command buffer. And then a debug command buffer. Two, we need to just throw them in the header file. So wherever that internal thing is, we need to drop these little buggers in here. And there you go. So now they're usable. So fingers crossed. There we go. Oh yeah. So now we can use that in this sort of like back end thing. Oh crap. Alright. So this basically is when we yeah, we're just setting up. So when we when we instantiate the oh no, it isn't. Oh yeah, so it's when we start a frame, we just poke the correct Vulkan buffer into here because we sort of double buffer them and they change every frame. So all we're doing is we're just sort of like updating those. Okay. What is this one? Right, and then the printf buffer that allows us to read back printfs from shader code. Hprintf buffer. Alright. So, okay. Let's look around for any to-dos. Right. Oh, this is a temp allocator thing. Let's use our frame allocator, which would be good. But we've got to clear every frame. So it's something to remember. So, interestingly enough, right, to do temp allocate this, right? So basically all of these Okay, so what we want to do is, wait a minute. Linear allocator, this one. We want a so we've got a set cursor, but we should really have a clear, which just clears the whole thing back to 0. So we should really sort that one out first, not gonna lie. So set cursor, it'd be like that. You'll set cursor back to the start, like that, and then we'll just like mem set up to the cursor basically. Right, just mem set all that back to 0 again. And then set it back to the start. Excellent. So that would be super handy. So in the main, we want, so really we should do this like per thread, right? But we've only got one thread at the moment. What we should do is we should clear, probably here, we'll go core linear allocator clear, and we're just going to reset the memory every frame. So that'll be at G game TLS frame allocator, right? So we'll be using the frame allocator for all this temporary stuff that we just want to recycle memory every frame. But yeah, it will be super quick. So when we instantiate our backend, so this is kind of like in the initialization, we're going to put it into the temporary. So we'll have this nice linear allocator called the frame allocator, and you know it's temporary lifetime. So and so you know when we start up the game, where's the main function? So we'll start up the game. I've got this test code in here, but anyway, we start up the game. We call it GPU initialize, and that calls into the backend, right? It's essentially going to like write into this memory here. Maybe it gets to there. When it does some temporary allocations. Then when it gets to the start of the frame, it will just clear it back. It just goes back to 0 again. 0 is all that memory, and then you get to use it again. But this time, while we render the frame, and then while we render the frame, it'll just fill it in some more. Maybe it gets to there, that frame. Then at the start of the frame, again, it just clears it. Right? So it's all memory that just lives for the lifetime, a very short lifetime that doesn't live for longer than a frame. So yeah, so here we're sort of like getting all these layers and stuff like this. So really we should call this twice. So one pattern that these APIs have in Vulkan is whenever you have like some form of like enumerate whatever, it takes in a pointer to a count as the first argument, and then it takes in a pointer to the stuff you're extracting. So you can actually call it twice, right? So if you call it without a data pointer, it actually gives you back the count. And then what you can do is you can then actually allocate the memory, like so, using the count. So you'd just be like, oh, equals core alloc array. Array of these guys for me, please. I want to use so now we're going to get the frame allocator up here. So we're going to do that. We're going to say core allocator, frame allocator. And that'll just be equal to game TLS frame allocator. Right, done. So we've got it there in a nice little local. Bear in mind, I do want to do a... Okay. So now what we can do is we can use that custom allocator there, just bump allocate the memory, and we're just going to say, right, we want this many layers, exactly as many layers as the Vulkan system told us that it has available. And then we call the same function again, and we actually call it to, and this time we call it with the count, like the count will be initialized to maybe 37, right? We call it with 37, and then the actual pointer with the 37 elements that they can write into, and then we get the layers. So we'll be doing this throughout this thing, right? I guess no mem fragmentation. Issue here. So, no, there won't be any fragmentation, right? Because you're not, allocating this region, allocating that region, allocating that region, and then deciding to then free this one back, right? So now this is free and available to use, right? Yeah, so now this one here is free and this one's free, but next time you allocate, you want to allocate like a little bit more memory and it doesn't fit in here. Yeah. So we're not freeing any, we just free the whole thing. So yeah, you don't get any fragmentation. No. Yeah, that's one of the benefit. That's another benefit of these allocators as well. Like the benefits are they're simple, like dead simple to write and understand, very fast because it's very simple. The most simple implementation. What else? No fragmentation. But the downsides is you can probably waste memory. You could probably end up wasting memory if you're not smart about how you clear it, right, or how long your stuff lasts. Like have got a good point where you can reset the whole pool back, right, to 0 again. Yeah. But yeah, I'm not sure when we will need a new different allocation strategy. We're going to try and go as far as we can with just using a linear allocator. And you know, I'm sure when we start doing some proper like interesting stuff, we're going to need a different allocator. But for now, these are just going to do, and it keeps it nice and simple. Any idea how Vulkan memory allocator handles buffers? Which one are you referring to exactly? Are you referring to the CPU allocator or the GPU one that AMD has made, VMA? Because there is one called VMA, right? It's really annoying. It's called the Vulkan Memory Allocator. Yeah, this one. Yeah, the AMD one. Right, gotcha. Yeah, because in the Vulkan API, they've got every function takes in an allocator, and that's CPU side. But yeah. So the question is any idea how the Vulkan reallocator handles buffers? So the Vulkan memory allocator, from what I remember looking into, it's a very over-engineered piece of tech, right? They basically support every allocator under the sun, pretty much in the code base. They even like emulate a sort of a standard vector in a way. It's really weird. I don't know if you've seen the file. It's quite big. But yeah, I guess it's okay. Like I don't know. I wouldn't advise using this, to be honest. It's very over engineered, but some people use it and they think it's fine. But then again, it's not a hard problem if you want to write your own allocator. But you don't have to write your own allocator, right? As well. But yeah, they even like if you're talking about vector. No, VMA vector. They've like emulated for some reason. I don't know why you'd ever need this, but maybe for like custom compute stuff or whatever. I don't know. But they sort of like have like they've implemented their own a vector class that sits on top of GPU memory or something. It's really weird. Just because you might want to have one. But yeah, they do like pool allocators. They do uh what else do they do in here? But it's very extensive. BMA pool. Yeah, they've basically implemented them all. Like, there you go. Oh, I don't know, maybe. But yeah, it's a whole bunch to read through. But yeah, I typically just write my own allocators when I need them. Like for now, we're just going to be calling directly VK allocate memory and just not being intelligent about allocating fixed things and sharing them out because it's not a problem we need to solve right away. Basically, but yeah, in the past I have done it, and it is a bit of a pain in Vulkan, but yeah. Like if you've used DirectX or Metal, those APIs for allocating memory are like way better. Yeah. Whereas they're more opaque in Vulkan is the way to say it. They're these hidden sort of enums, whereas in Metal and DirectX, they're basically they're like an enum, right? They're fixed. You understand them. You can see it. It's kind of transparent. But yeah, we're gonna do it for the same thing we just did for the layers, but for the extensions. So the idea, right, is duplicate that, pass in null for the first one, get back the count, allocate the memory for the extension properties, and then voila. So, oh come on, there we go. So nice, quick, temporary allocated, and dynamic. Rolling your own allocator is good, but things like memory compaction in case of fragmentation needs for expertise. Sure. I don't know, but again, yeah, it just entirely depends on your problem, right? Um, you know, like if you have a general purpose allocator and you're kind of doing like, in my opinion, general purpose allocations are like not like they for the most part can just be avoided. And there's always a specific strategy you can deploy to your problem. It does require specific code, obviously, and time, but it means you can get away with less, basically, and less issues, less potential problems. But yeah. Like, for instance, you could bump allocate your GPU memory, and then you don't have the fragmentation problem because you've statically created it all at boot, right? And only when you resize the screen or when you change your quality settings would you need to reinstantiate all of it, right? So there's different strategies you can deploy depending on your game, right? Um, right, so this is another one with the physical devices. Same thing as that enumerate thing, which is pass in the null. Physical devices equal, so just drop that and then say allocate me an array, please. Frame allocator. Then I want to have physical devices count worth of those. Thank you. Pointer. No worries. Um, Yeah, so this is really bad right now. Okay. So we just select the 0 physical device. So you could have 2 GPUs in your system and I pick the terrible one, depending on which one is which. So, to do proper GPU selection, right? We could be selecting their integrated graphics. Or right now, this is bad. E.g., we could be selecting their integrated graphics when they also have a dedicated. We also want to check for features, right? Yeah. Check for feature compatibility. Stuff like that. Cool. So, anyway, next one. So just hopping around, find some more things. So, max resource descriptors, is this too many? Good point. That's not today's problem. Custom memory allocator, please. Here we go. So this is the malloc that we do, right? We have all of our descriptor updates in memory. And yeah. So this can be done with a static allocator. So we'll get that at the ready. So there's a malloc. Right. So we use that descriptor template thing to basically allow us to put all these descriptor updates in memory. So descriptor is basically the shader side representation of a buffer or an image or a texture rather. And it has like a data pointer to where the buffer is and some other extra information like how big is the buffer or how big is the texture, what settings, stuff like that. So you have to update these from the CPU side and they get poked into some GPU memory and the GPU can use those. So we just do it in a way which allows us just to have it all in some pre-allocated memory, and we can just call do one function call which is like update descriptors with template, passing that range of memory, and it just does it all in one call. I'm not sure how efficient this is. We could probably reduce the size of the array and make it way more efficient, but for now, I think it's a good approach for now. But anyway, we need to actually allocate this properly. So we're doing like this. We just need to use the core alloc, passing the allocator to be the static allocator. Do we need like an alignment? Probably. So we're probably just going to align it to the size of our pointer. I don't think we need anything. Yeah, else really. Maybe U64. Let's try that. Cool. So let's keep going there. Where's the to-dos? So yeah, there's this xlib thing. We could maybe avoid forward declaring it. We don't care about that. For any more temporary allocator stuff we can do. Can I ask a question? I'm learning Vulkan. Of course you can. Ask away. If anyone has any questions about this code base or Vulkan or programming in C or something, ask away. We're just doing a bit of a kind of like a tidy up stream in a sense. So yeah, questions are welcome today. Kind of more than usual. So you use in Vulkan memory allocator and renderdoc gives me this performance warning. Unmapped memory ranges 177 overlaps tiled only memory region. Taking slow path to mask tiled memory rates. Interesting. So you're running on like a desktop, right? A desktop GPU, is that right? Are we talking? Like, what GPU you got? Let's start there, I guess. Okay, it's a laptop. Yeah, I didn't realize. I don't know if there is a laptop which has tiled-based memory, but maybe they do, right? But yeah, what sort of GPU integrated graphics? Like an old AMD. Yeah, I think AMD would not be a tiled memory. So I think it's more of like a Vulkan API um, thing that it's running into. So it's not necessarily related exactly to the tiled memory, but it's what it's warning you is like if you were to run this on a tiled memory thing, there will be a problem. So I guess we can dive more into that. So unmapped memory ranges overlaps tiled memory region. To mask tiled memory rights. Oh. What do I remember before? No. Oh, maybe that's something different I was remembering. Taking slow path. I have to think about that. Do you write your C in OOP style? Not really. I still have like a sense of like an object has its sort of methods but they're functions, right? I still have that, but that's not really OOP. You know what I mean? It's I still have functions that work around the concept of like an object, but yeah, not OOP though. You think that the system RAM is not big enough to map GPU memory pages? You think? No, but it would just be address space, wouldn't it? I don't know. Also, the weird thing is saying is unmapped memory. Memory 117, so specific sort of device memory or something, overlaps tiled memory region. So the thing that you're, so some texture, on the top, no, some tiled memory thing. Are you using transient resources there? What's up? Or are you just doing like a basic triangle? Are you using transient resources? Like, are you using subpasses and doing stuff like that, right? Are you trying that out? Basic triangle, right? It could be something to do with the right. It could be something to do with the thing it's selecting. The memory type. You could be selecting the wrong memory type. You know, is it doing memory types? No, transient resources is to do with when you do subpasses for resources that live for the lifetime of the subpass. So, as an example, drawing time, you have a render pass, which maybe renders to these two images, right? And then in the next subpass of the render pass, it takes those two in and renders this image, and then it actually finally outputs this image for some reason. I don't know. right? This is all one big render pass that you can do. So basically, right, this one, and this one is a transient resource, and at the end it outputs this one texture, right? Or you can set it up that way, meaning that this could all just live in tiled memory, and the draws can run in a different way, and but only on mobile chips or a tile-based GPU will it do this, where it will sort of like keep it all in tile memory, and yeah, it's got a transient resource. It's really makes the API really complicated. Trying to do upload image buffer staging buffer thing. Yeah. So I would look into maybe yeah. Do you know about your so it could be to do with the memory types. You know what I mean by that? So when you have your so let's go for instance on the Intel, right? Intel integrated graphics. So when you go you probably give them a memory type, right? When you allocate your memory. So this has got 3 memory types. One's device local, one's got like host visible, and that could this be a little bit wrong? Like maybe you're selecting the wrong one. I don't know. Maybe. Oh, you don't know how the VMA does the memory type, right? Yeah, I'm not really too familiar with the VMAs. And also, why is it saying tiled memory region? I don't know. Yeah, I don't know. I think you could be having a little bug with RenderDoc. I have no idea, or unless it's trying to figure out something to do with the spec. But I would just ignore it, because if you're not doing anything to do with mobile rendering, basically that error is useless, right? If you're just doing desktop programming and you're learning, like just ignore it for now, because like just until you get more of an understanding of those things. Yeah, mobile, like rendering on a mobile GPU, because tile based, like if you're trying to make it run on Android, like those are tile based renderers, tile based GPUs. Um, and that error sounds like it's kind of talking about that, basically. Like, is it causing you an actual problem? Like, it's crashing it? Yeah, the Mac and iOS are tile based. Yeah, yeah, they are. Yeah, so the Mac is basically the only exception of a desktop tile-based GPU. Yeah, that is true. Hey there, Machine Knob. How you doing? Hey there, Backen. Bacento. How you doing? Welcome. Do we need to allocate this memory? Oh, this much. Of course we do. Of course we do. Right. Any more little temporary allocations that we can find? Oh, there's another one. Excellent. Okay, so we need to temp allocate these guys. How are we going to do that? So this is when we are frame start. So when we start the frame, we want to upload, do our staging buffer basically, right? So, yeah, so we just want to like do some sync code. So it would be nice to know these upload entries, it would just be nice to know, like, you know, I'm uploading 3 buffers, 2 textures, or something like this. You could do some barriers. No, we can just max allocate it. It's not so bad. So we'll just be like, sure, we'll just say equal. So obviously these are both pointers. And these are going to be temp allocated, so we're just going to say core alloc array of this image thing. We're going to use the frame allocator. Bear in mind, I do have to go and actually fetch this and put it at the top of the function. Voila. And then what we want to do is allocate basically entries count worth of those. Maybe +1, just because we do... Oh, we'll do another one here. I don't know. Awesome, good to hear. Yeah, so to get the number of upload entries count, that's core stack count, take the address of ggpu upload entries, which is this new dynamic array thing that we have. So that's the new way of doing it, like that. Allocate those guys, get some little counts at the ready. We fill in those buffers as we did before. And we simply, right, so this is we need to do a bounds check to get, so core stack get, take the address, index, okay. So this is just doing some barrier stuff, right? It's just saying, like, you know, we're just, before we upload the data, or copy the data from the upload buffer into the upload destination. So, you know, we have a little staging buffer where, you know, I keep drawing these are amazing. Well, we basically just like write into the upload buffer some more, right? And then there will be some other buffer on the GPU, and there might be some texture on the GPU. And basically, this is a staged update, which is updating this thing here, right? And then this is an update that's going into this one here. And yeah, all we're doing is simply transitioning these resources, this buffer and this texture, to be ready to be copied to. Basically, to copy the update to. So we're just going to do this transition. And yeah, it's just going to say it was being... this is how it was being used before, and how it's going to be used afterwards. It's going to be written to via some transfer. It's overly complicated code, but yeah, it's the way Vulkan is sometimes. Yeah, so that's all this code does. And then after we've transitioned it into a state where it's like, oh, I can be copied to, then we actually perform the copying. So we go over, let's just get this at the ready. So then we go over all of the copy entries, and we actually just record into the command buffer that copy buffer or copy buffer to image, where it copies from the staging buffer to an image or to a buffer, right? Basically, you know, and then core stack get, and then we simply, then afterwards we transition it from being in a copyable state back into the state that it used to be in, which is maybe like, hey, I'm used in a shader for read only, or something like that. So that's all it is. Now we'd need to obviously allocate some more of these temporary memories. Bear in mind, we could have just reused these ones. But yeah, I'm just going to waste some memory, because it's not wasted, because it's already there anyway. Cool. And we just delete that. Do the transitioning. Right, so let's see if there's any more temporary allocator stuff we can do. To-do, we should split this into, yes, a good idea, but not for now. This one is a temporary. Oh yeah. So this is just when we do more resource barriers where we transition the states. Again, more state transitioning. So we need to do that. Again. So simply, we can just do the resources count here. Like that. And then, yep, so we just temp allocate the maximum amount, put them in there, and voila. And then we do the pipeline barrier, which does the state transitioning. Cool. Right, what's the next one? Any more to-dos for these sort of like temporary allocator things? To-do, temp allocator, max allocate resources count. So this is for read back. Right before... Wait, does that need it? No, it doesn't need it, because it's just on the stack. Yeah, we'll just use the stack, it's fine. It's just 2. So we don't need it here. We don't need it here either. Right, it's a swap chain silly thing. Using FIFO right now for some reason. Yeah, alright, we made it full circle, there we go. So apparently we've gone through all of the stuff in the back end now. We kind of want to, well, there might be some more, so let's just grep for all the to-do labels and just see what we got. And let's see if there's any more temporary allocated stuff in our code base. So we can ignore the back end. There's... looks all good. Wait a minute, what's that? Let's look for object pool. Right, resource. Okay, no, it's fine, it's fine, it's fine. Subscript value is not an array. Okay, so we just need to use that core stack get to just get that entry for us. Wait a minute, is this just in a push? Yeah, it's just in a push. Even better. Like that. Excellent. I got some more things here. I guess that's just another push. So this is when we upload to a texture. We're just pushing in this sort of like host copy entry where it just keeps note of like, oh yeah, we're copying to this thing from this CPU offset inside the upload buffer. And then the destination texture, you know, the offset is the destination texture and how much you're copying in there and that, what MIP and array layer. Right, so this one is, every time we submit, we want to clear the upload entries. So core stack clear. We're going to clear the upload entries stack. This one is talking about iterating over all of the core stack count. So when we call sync resource, what is this doing? Yeah, it's just something. If the resource has been written to in the previous dispatch or current dispatch, none of them are readable and none of them is specified, add it to the list of resources. I think right before the next dispatch is issued. Right. Yeah, so this is just our manual sync code when we say sync this resource for me, basically. So if it's writable, I don't know. I might have to revisit this code. Maybe it's fine. Core stack get. Then this is gonna add a new one. Right, so it just deduplicates it as all. Right, okay. Push. Dereference push. Done. Awesome. This one wants to get the count. Okay. So when we do a dispatch, if there's resources that we synced on, so the way our API works is it requires explicit syncing for now. So you just say sync on this resource. I'm using this buffer as read only. Sync resource. I'm using this texture as read write. And then next time you call dispatch, it will go over all of those that are accumulated, and then it will call resource barrier to do a pipeline barrier and put the proper sync code in, and then do dispatch. So it's not really like it's the quick and easiest way to do sync code, but it's not obviously the best way. But it's far easier than other methods. So we go over these and we what do we do? Oh yeah, we set the states, right? So core stack get, take the address, do a deref, then we clear this out. So core stack clear. Oh, hopefully we should be there soon. Right, so we ain't got a queue ID anymore. Why? Right. Yeah, we really need like a queue enum. So it'd be like read back queue test, right? And so this is test our readback API. So the way the readback API works is when you start the frame. Oh, hey, welcome back, Russell. How you doing? Welcome back. Yeah, so the way our readback API works, if you guys don't remember, like when we start our frame, we're allowed to start recording into a command buffer. And because of that, the readback resources are now available. So what we can do is we can do a readback start and then do a manual readback this way, where we can basically go over the queue for each readback So we can go over each queue if we wanted and get the data to read back basically. So we're reading back a whole texture and just making sure it is a match here. We've also got some read back commands from the GPU if we wanted, but yeah. Yeah, so it's all there ready to be used when we want to use it. Excellent, so now we're here. So we want a GPU initialize, so we're going to do GPU spec. And we're just going to, get this. Let's get all these guys and figure out. Okay. So how many readback queues we got? So, we should really put a proper number in here, but let's just put 1. How many resources? Let's just do 1024. We can always tweak this number later. How many resources per dispatch? Let's say 32. That's a good number. Wait, probably more than we can support. Because if we've got a bundle constants capacity of maybe 64, and they're 4 bytes each, 16 really. So maybe we upped it. But yeah, let's say 16. Max uploads per frame. Let's say 256. Max autocopy readbacks, let's say 256 as well. I'll just put a good number in there. And we'll just initialize the GPU system there. Boom. Right, so apparently it all compiles now. We've completely switched over to using our new dynamic arrays, dynamic allocations. We've got our new custom allocators. So we've completely switched over now. I'm pretty sure. Is there something else I'm missing? Yeah, I don't think we have much else. We just have the whole GPU system. There's probably something in OS that we should probably do, but it's not for today, I don't think. Yeah, I think that's it. So if we now... yeah, so this is probably going to crash and burn, let's see. There we go, as we expected. So the QE num is out of bounds. It shouldn't be checking that. 296. So this one is saying it'll be less than count. Right, this one has got to be... I don't know. Because we should have upped it by 1, right? Q enum, that should be... Oh, my days. Yeah, auto copy. Right, so this one should allow for if it is auto copy. Something like that. Read back texture. Now this one's failing. How many readback keys we got? Two. So the QE num is... Why is it? Oh, auto copy. Oh my days. Right, so I guess we just got to stick this in everywhere, and I don't know... from the public API, they could just accidentally put -1 in maybe, and they will get access to the auto copy queue. So it's not really good. How do I keep track? Hey there, Sherlock. How do I keep track of all different responsibilities you have with Vulkan? Well, when I started this project, the first thing I did is literally get a window open and then get right in there and design the GPU API I wanted, and just get all the Vulkan code out the way and basically done with, and try and tackle it in a very simple way. So the idea is that when we come back and edit this code, it should hopefully be quite minimal. And but yeah, how do I sort of keep track of all the things I had to do and everything? That is definitely comes from practice and doing it before and understanding the API quite well. But yeah, tons of flailing around in the past and figuring out like how does this work, and what are the restrictions of these things and how they all work together, because it is very complicated API. It's not a good one. It's not an easy one to learn. But yeah, so we've just focused on just designing something very simple that we can just use, and so we're just going to hope that anything we do with Vulkan from now on is quite, just making it work on more systems, basically, until we, yeah, through the R&D phase. I don't think there's be too much work on it, to be fair. I hope that answered your question. If not, you can ask another one. Yes, this also copy queue thing is like, we kind of just need it everywhere anyway. It's kind of annoying. But I guess it's -1. And if they're using an enum, it's proper hard to trigger it. So you know what, we're going to do the thing. We're just going to do the thing where we're not going to put the check in. Yeah, so this out of bounds thing, we're just going to do that. Oh, well, I don't know. It's really annoying. Okay. This is what we're going to do. We'll do that check. This is fine. But -1. Right, excellent. So when we're not going to do this, like when this QEnum equals also copy, make it the last. Instead, it's just going to be the last. So this is not going to be a constant anymore. Instead, it's going to be a function that returns when it's GPU read back enum, and we're just going to say read back auto copy queue, and it's going to just give you the index automatically now. So I don't know if we need another one of these. Is that right? Yeah, so this will just be deleted now. Excellent. Where's the internal? Right. We need that one. Excellent. So just underneath here, we're literally just going to return like, okay, return GGPU, read back count, take 1. All right. So that is never a thing anymore. And then we just literally we'll call it QEnum. So now we can just call this function internally, and it'll solve our problem, and then we can just move on. Get rid of that. Right, so see this crashes and burns? Oh yeah, we're back. Look at that. There we go. So there's our code base now using a super lovely our new dynamic allocation. Yeah, new custom allocators, new custom arrays, and object pool. Right. Sweet. What's the color scheme? Yeah, so it's a little custom one. It is based off of another theme, but it's heavily modified. But yeah, it's basically like I used to use Iceberg Vim. So it's like a blue one where it's just like a couple of colors, and then I was like, I kind of want one that's more red. I want to do something a bit different. Um, I was looking all around and couldn't find one, but I saw like another theme that had like a decent background and maybe and used I think these colors somewhere, but I just basically heavily modified it after that. Or was it using these colors? I don't think it was using all of these colors actually. Maybe that's a lie. I think I picked the red or something. I forgot what it was. I think it was only yellow, and then I picked the red, and then I applied it everywhere that I wanted, and applied the yellow in more places. Yeah. So it is on the Discord somewhere. I have to. I think it's in chit chat. You might have to search theme, something like that. I don't know. Maybe I can find it. But yeah. If you ping me on the Discord, if you can't find it, I'll link you to it. Do check out my Mayukai theme. Mayukai. Let's have a look. Theme. Ooh, Microsoft Day. Mayukai. Yeah, it looks very sweet. Very much like, as Americans call it, candy, Looks very nice. But yeah, I think one of my gripes about themes is they're just too colorful. Like, I used to like stuff like this, but I don't anymore. Like, yeah, they're just like super colorful, colors everywhere. Yeah, for me, I'm just like, I like just two colors. Well, three if you want to include the background and maybe maybe I don't know, four, maybe the white. But yeah, I typically just like two different colors and then black and white. Missed a few streams. I'll check out the YouTube videos, understand what's going on. Awesome. Yeah, so for those who don't know and want to catch up on this, we do have, right, a VOD channel. Where you can go back and watch it. Obviously, you can watch it back on Twitch as well, but YouTube has the whole thing. There is also a YouTube channel where I do devlogs, and if you watch literally episode 0, it explains exactly what this project is. Well, no, not exactly what it still misses what game are we making and that, but it describes like why we're doing this project and what direction it's going in right now. I'm probably due another devlog soon, just to talk about this new collection stuff that we've been doing. And then there's a Discord where you can come hang out and ask more questions off stream. And yeah, if you want to get access to the code as well, if you're already a Twitch subscriber, you can get access to the code and have a play on your local machine. Works on Linux and Windows. But also, if you support on Ko-Fi, it's the same price, but it just sends a little bit more of the change my way, because Twitch likes to take 50%, and Ko-Fi is a bit more generous on that one. But yeah, there's all this. Awesome. Right. So let's commit this, but we've still got like so much time left on this stream. So like, what should we do next? Like, we're switched over to using this new collection thing. Like, should we just make a start on keyboard input today? Because that is the next thing I'm gonna do, and I thought I would have, I thought we were doing more stuff today. But I don't think there's much else. So what we plan on doing next is keyboard input, gamepad support. Because ideally, when we're doing some R&D stuff, right? What we want is so we've done virtual memory, we've done these custom collections, we've just got them all plugged in now. Nice. We ideally want to do some more core engine bits. So when we do some R&D, we're not stopping what we're doing and going back into doing some core platform stuff, you know. So I think let's just get started on the keyboard input today. We'll go over that. So I guess we'll change the stream title a bit. Yeah. So keyboard input next. So just to warn you on this one, if you are following along on Windows or anything, right? We are gonna do it on the Linuxes first, right? But we will do a Windows stream in the future. So I think we might do the keyboard and gamepad on Linux first, and then we'll implement it for Windows, because I really want to make sure I get the interface right, and then go over and do it on Windows. I don't want to do sort of like, oh, let's do the keyboard and then go over to Windows and do the keyboard, you know. So it will be done, the keyboard and gamepad will be done together, and then we'll go over and just do it all on Windows in one go, hopefully, or 2 goes. Yeah, so let's get this thing committed. Git status, just have a quick little look. So I added 2 new little files. So we've now like move over. Okay. Make the code base use the new allocators and collections. Oh yeah. So we're just going to push that up. Wait, what are we doing? You can use a Logitech gamepad. Why a Logitech gamepad specifically? I've got some PlayStation ones laying about, obviously, so I'll just be using those probably. Because it's all supported in the Linux kernel, and it's on my desk, so, you know, let's do it. Oh, like the submarine, oh my days. Yeah, I'm clearly not rich enough for those Logitech gamepads. Yeah. Oh my days. Yeah, so we commit that. So we can now do a push. You know, should we do a day whatever on this? I don't know. Should we tag it? No, we'll do another commit hopefully today. So yeah, I'll push it up. Oh, what am I doing? Git no, I need to log into Bash and do that silly dance. Right, so for those of you who want to get access to the code and just have a play around what we did today, or who have access, you can just go and do a pull round about now and get access to that. Cool. Next one. What do I want to do? So we have an operating system layer. So there's an OS header. You know, let's open it up in Vim. Vim is, you know, it's juicier. Let's close the discords. So right, let's close all this. Let's open up the we'll open up the core header still. You know, core is good. Now I'm gonna open up the OS header. So we have an OS layer where basically we have this interface that we implement across all the operating systems that we support. So we have stuff for, we've got a little result. So for all of our, you know, if it's a success or some error code, We've got an event thing. We also have some windowing in here for some reason, but it's under the event thing. That needs to get cleaned up. We've got some way of opening a DLL and loading, finding some symbols and, grabbing a function pointer. We also have a virtual memory abstraction. And basically, like, all of this is implemented on Linux and Windows in a separate file. And yeah, so basically what we want to do is extend this event thing to support keyboard input. So what we're going to be doing, so I guess, should we split some of this up, so I think, like, with this game, right, I'm not really fussed about multi-window, and if we ever want to do multi-window, we'll just do it then, right? I think, I kind of like, what did I kind of like assumed we would do multi-window, and yeah, I just doubt it's gonna really ever be a thing. So, it is nice if you can have like multiple windows and but it really adds complication, and I just don't know if it's going to be worth it for a long time. So for now, we're just gonna not do that. We'll take that OS initialize, put that at the bottom. And then we kind of maybe want like a file API as well. Let's put that in there, file. So we've got like a file API to read all files. Alright, there you go. So what we're gonna do now is open up the main window. Maybe when you just initialize the backend, it just opens up a window, right? Just void. Is this game multi-threaded? It's not yet, but we will plan on doing multi-threading in the future when it actually matters. But for the longest time, okay, throughout the whole R&D period, so when we do some graphics research and development and also figuring out what is this game, we're not going to do it because it's purely just going to get in the way of getting to the R&D faster, right? But I'm sure as soon as we got when we know what we want to do, it's probably going to be one of the first things we do is get a nice multi-threaded system in. And the reason is because trying to retroactively put that into a code base you've already written can be a bit of a pain. So it's just good to start off with something that you're going to be doing. And just, the code is based off of the multi-threaded design from the beginning, right? I definitely play code first soon would be such a good example for me to get into writing good abstractions and also moving towards C over C++. Awesome. Thank you so much. Appreciate it. Yeah. If you have any questions when you pick it up, just again, Discord, feel free to spawn up a chat over anything if you have any questions. Well, this already answered that question. Next one. I've done the Crafts and Interpreters book in C, very cool, and read a good bit of C-based game code, but never jumped into really trying it myself. Okay. Yeah, 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 like, yeah, like, I don't know, it's all different really, like, when you write your own engine, the, you can really, I don't know, There are some elements where it's basically the same, you know, like you have a main loop or and stuff like this, but if you have your own engine, you can really yeah, make the code feel different. Yeah. Okay. What do I want to do? What do I want to do? Yeah, so let's rework these changes that we made into the OS Linux side of things. We're also going to open up the OS Linux internal. So this is like, you know, what I like to do is have a public header, which in this case is just os.h because that's the main interface across all of them. I like to have an internal header where it forward declares everything, puts all the types into place, so we can put comments there or just see a zoomed out view of everything. And then I like to have an implementation file. And these things you can just get as big as they can get. Like, so they might start off looking small, but some of them can just get huge. And it's just the way I like to work. So what we have in here is the OS Linux global. It's got one window in there, right? We're also going to potentially do multi-window. We're not doing that anymore, right? Maybe never do it. And yeah, so we're going to be probably making little changes to this. Yeah, that's what I remembered. I want to change the title. It's now using collections, okay, and keyboard. Keyboard input, right? We're making a start on this right now. So, let's have a bit of a rework. We're dropping this at the bottom. Well, right. So there's like a main function, and then we kind of want to have like, I don't know. OS bells and whistles, I don't know. Anyway, so let's just get these sections all in, right? I've already done it there. Nice DLL, nice. This is a file read all. This was kind of near the top. There's a file here. This window open, I would like to say we're going to have one of those, but remember it's internal now, so it's going to be called like OS. Like we're just going to say as soon as we initialize the OS system, it's just going to go ahead and do that, right? So I think what we want to have is something like this, and we'll put it like near get last error. There we go, and we'll just call it when we instantiate that. Yeah, so it's just gonna call like, you know, x create simple window. Yeah, I think we should really call x create window, but maybe simple window is fine. Anyway, so window open. Yeah, we should really call that inside OS initialize now. Like right at the bottom. And you know, we don't really have a window size right now, so we should like to do wait, do we? I don't know. $800, $600, whatever. Nice. Let's do some more shuffling. So we want some Windows specific bits, like, you know, can we get the backend stuff so when we create a Vulkan instance, we can give it like the display connection and the window handle. But we have it in more of like a typeless sort of fashion, just use void pointers. So we don't have to export like X11 types and stuff like this, right? We just sort of cast them into those void pointers and get away with that. So these just become a couple of void pointers. Void parameters. So nothing basically. Then the event. And then DLL. Excellent. Right, we're in. So let's just make sure we have actually done a good job there. So now we're going to open up the main file, okay? And we're going to do an open window here, or we used to at least, right? But now that is no more. It's just done automatically inside OS initialize, which calls into the backend, right, and does it all. So this gets deleted. Nearly there. So this just gets nuked in the Vulkan side of things, and this gets nuked in the Vulkan side of things as well. And compiles and runs. So now we could probably commit this, right? And just say, let's just put a nice little commit in. And you know, we've just what have we done here? We've like reorganized. Okay, we just want to say like clean up. Okay. Make clean up os.h and make window, and you know, make a focus towards a single window API. Okay, if we need more window, we're still here. Right, so now we actually want to make a start on this keyboard input thing. Okay, so I guess let's talk about like all right. So basically, like when you press a key on the keyboard, the operating system will process it, and I think it's called I forgot what it is on yeah. So the kernel processes it, and then on Unix-based platforms, you have like X11. So you have like the kernel. I don't know what I'm trying to do. Kernel. You have the kernel. And then you have like X11. Now, I think it's called environment dev. So env dev, right? I think so. No, maybe that's not right. Maybe it is right. Linux kernel keyboard file descriptor, because everything, you know, you access it with a file read. Which one is it? FD? No, it's not right. udev, right? It's udev. It might be udev. Yeah, so yeah, that's it. You do need, yeah, that's correct. That's correct. So the thing is about udev is you can't read it directly, but you can if your root, I think, or maybe you can't read it because X11 already has it. I forgot what the restriction is, but basically there's a thing called udev. And you can like open up a file descriptor for it. You know, you can read the events back, read the key codes that are pressed. So imagine like you do like an F read on a file, and it blocks and it doesn't return until you press a key. And when you press a key, it returns, and you can process that information. Now, basically, X11 opens up that file descriptor and does that bit for you, right? And then it also does some extra bits on top, like events. Like it gives you nice little events where it can interpret like a key press or a key release, but also it can do some translations. If you enable this XIM thing, where you can get it to basically give you proper text box input feedback. Like, it gives you the proper key, like the string information, and everything. So X11 is really handy in this regard as well. It does lots of extra stuff which really come in handy. So if you were able to bypass X11 somehow, it still is just beneficial just to use X11 because you'll be using it anyway, and just use their things. But the thing to take away is X11 still gives you, like, you can still kind of get the raw input feed from the current that it got, but only filtered to your application. So what I mean by that is they give you this thing called a key code. They give you a key code. So imagine like every key on the keyboard gets an enumeration entry. So imagine if you just let's start making one, right? So we're gonna say key. We'll call it key code. So we're gonna call it like OS key code A. So this represents the A key, and then this one represents the B key, right? So I think there's like a udev enumeration, right? Basically, and the X11 one is like 8 plus the udev one. So if you want to get the udev key code back, you just take away 8 from it, and then we can use that. We can use like a udev lookup table to translate it from their enumeration into our cross-platform enumeration that represents the key code. Now, there's two things there's two things to take away when I say the word key code. So what key code is? So I think we're going to go with like the SDL2 sort of terminology. It's quite good. So they have a scan code and a key code, but ours is going to be a bit different from SDL. We're just going to have an enumeration all the way, whereas SDL likes to make their key code like a char, like a byte, which is like represents the ASCII thing, whereas ours isn't going to do that. It's more of like, so if we say the word scan code, what we mean is the physical. Let's go open a QWERTY. We mean it basically maps to a physical place on the keyboard, no matter the layout. So it just reflects like the QWERTY keyboard layout. So if we were to say, scan code T, it will be here. But then it'll literally be here no matter what the layout is. So if I were to get a Colmac, which is the keyboard layout which I use, so mine's different. So this is Colmac. So T is here, right, instead of here. So when we say scan code, right, scan code T is actually G on the Colmac keyboard. Now, if I were to say key code, key code respects the layout, and key code is down here. T is here, and on QWERTY is up here. So this is the terminology we're going to go with, and you're allowed to translate between key codes and scan codes, and this is what we're going to have in our API. So scan codes are useful for when you want to make the WASD keys feel the same across all the different layouts, but key codes are sometimes used for where you want something sort of that is very is the word phonetic the way of saying it? I don't know. Like where like the number, or where it's sort of the letter actually means or relates to the action in some way, and you might want to have that relationship. So yeah, we'll have both. Keycodes are useless, and most applications use them. I know, right? Most applications default to keycodes. Yeah, I think there are cases where they are useful, but yeah, you should really default to scan codes, though. That's correct. But yeah, we want to have a bit of both. Oh no, here's the reason why you use keycodes. So the reason why you use keycodes is so you'll use scan codes, but you'll translate into the key code so you can display to the user the string representation of the key code. So if I were so basically like on when I save your key map, right? I'm saving scan codes out. So if I'm saving scan code T, right, out, and then you change all your layouts, right? You change it to Colmac or whatever. It doesn't matter. When you load up your Colmac, it will tell you that it's mapped to G, right? Because I've just translated the scan code, which was saved from disk, into a key code, and then I've just said turn that into a string and display that to the user, and that's there. That's where I think the primary reason of why we want key codes in the API is that reason. But I don't think like doing any key bindings directly against key codes has many applications though. Yeah. But yeah, how's it going, Nadila? How you been? Good to see you. Good to see you. So basically, we're gonna do a very similar thing to what like SDL does with their scan code. Is they basically just follow the USB model. Now I've already got a here's one I made earlier. Ta-da! So we're gonna copy this one. This is very much inspired by the SDL one. Now I don't know. Maybe I could change it. But yeah, so what we're gonna do is take this with us, and we're gonna plop this in. So yeah, does anyone have any questions around the what I've just gone over, and want to have some extra information, or does it all make good sense? So we're just going to replace WoW with OS. Playing Dota 2, awesome. I remember trying that game and I just got floored by everyone. I never understood that game. Right. Window abstraction layer to OS. Oh yeah. So I don't know if yeah, so this just follows like the USB spec basically. So we're on the USB keyboard. When you press a key, right, and send it down the USB, like it goes through the USB interface and gets picked up. Like this is the enumeration basically, right? The communication between the two devices. So by supporting all of the ones that the USB spec supports, theoretically you support every key, right? So that's the idea. The only thing is it's like maybe we can make it fit all within a byte and we don't have to use a U16, but then it probably doesn't overly matter so much anyway. But anyway, it's just me thinking about it out loud. So yeah, we've got OS scan code and OS key code. Scan code is the platform and keyboard layout independent enumeration that represents a physical key. And then platform independent enumeration that represents... Yeah. So by platform independent, what we mean is Linux, Windows, right? Yeah. So this does not use keyword mapping. Yeah. is used to reason a physical location on the keyboard. Use OS key code. Use the OS key code and enumeration values. Excellent. So, yeah, that's the sort of plan with this one. So there's going to be tons of like utility functions. I guess we'll look around and maybe get some of those. There's going to be tons of like lookup tables. But yeah, we're going to have like a way to turn it into a string. So we can display it to the user, transition between the two different things. So let's go and get these guys and have a bit of fun. So, right. So this one is saying, see, should I say OS keyboard scan code? It's a bit of a mouthful. I could just say KB. But yeah, I don't know. I doubt we'll be referencing this API too much anyway. Some interesting thing would be multi-threaded, multi-threaded and stuff like that. But for now, like we could capture the whole keyboard state and you have it in like a local, right? And you just pass it in and you sort of reference it. So is that a good idea? Because you kind of want to double buffer it anyway. Maybe we double buffer the keyboard state and I don't know. Well, it's read only, right? So it should just be fine. You just sort of like, so long as the threads that you are calling it happen after the initial event processing, then it should be okay, right? Yeah, I think it should be fine. So yeah, anyway, we have this lookup table which turns into a string. Very nice. Is the scan code pressed? Is the scan code released? Or has it been pressed, has been released? Is the key code pressed? And so on and so forth, right? Awesome. Yeah. You ideally want to avoid using key code to scan code, as multiple scan codes can map to a single key code. This function ideally allows you to get one of those scan codes. Scan code to key code does not have this problem. Excellent. But yeah, typically you want, yeah. And you will want to use this to display keyboard layout respected keys to the user. Something like that. Cool. So yeah, we should really so this is part of the API we're going to be implementing. Let's see if there's any sort of other public things that we might want to do with. Yeah, so I think maybe we'll just start with. Yeah, I think let's start with this actually. There will be a lot of plumbing in the back end though, because we have to use XKB for X11. Yeah. So yeah, let's hop into the. So why did we double buffer the keyboard input before? Because I think you want to check whether or not the previous frame had bit differed or something like this. Yeah, think about it. Yeah, okay, let's just go over the initialization code and we'll build it up as we go. So OS initialize. So now we kind of want to begin. So we're gonna do some X11 code. Let's try and find where we instantiate the XKB stuff. Yeah, bearing in mind this is X11, so It's going to be old and have some interesting elements, shall we say the least. So we first need to include all of this garbage. Well, not really all of it, but yeah. Get some more. So really, we want probably MD. We don't want xrandr, to be honest. That's a different thing. That's to do with displays. Yeah, we might need it at some point. Maybe XUtil, something like that. There we go. Let's get all those in. Right. So, it is environment and EV dev, right? Okay, EV dev. Maybe it's something different. Okay, we'll come back to this lookup table in a bit. So to instantiate everything, I'm so glad I don't have to write this code from scratch again. Oh my days. Right. So right. We want this XIM stuff. We need that. And then we need this X keyboard stuff. Okay, let's start with XIM. Let's just get that in there. XIM. Right. See, they've just got a thing called atom, which is really annoying. So I'm going to call it X11 atom. Super annoying. Right, so XIM is basically like, it will help translate key presses into proper text strings that you can just throw straight into a text field in your application. So this is all that is doing when we instantiate that, right? So we're just going to grab this, chuck it in here. So open up a display, plop that in there. So GOS Linux connection. Okay. So that's all we're doing there is opening that. Now I want to do the X keyboard stuff. So XKB. There we go. Let's get this. So this one. All right. Core debugger SERP for me, please. Right, what are we doing here? Backend X11 XKB. Get keyboard map. Right, I need to look up what that is. We need one of them. So we get this X key. Okay, we'll figure out exactly what this does in just 1 second. Let's just pump that in there. So we've got this XKB desk pointer, so some description, something. So we'll just plug. So GOS Linux, right? Let's plug that in there. All right. So we're setting auto key repeat on. I forgot exactly what this does, but this changes how the events work, where it makes it so. I think it makes it so that the off key doesn't. It does the auto repeat, but I think it doesn't return. Days. X auto repeat on. It says auto repeat on, but okay, it can't be that simple, can it? It might be. It might be. Maybe it might be that simple. Okay, maybe it stands on auto repeat. Okay. So we sort of like query the XKB. You know, this should probably be a proper assert, no debug assert, right? Because we want it to actually crash in release mode if it can't find XKB, which it should always find it, but yeah, when I crash, if it can't find it. Then we get this keyboard map. So I guess this gets the current keyboard map. So you'll get like the Colmac keyboard layout, for instance, right? And then, okay, this is the special thing I was thinking about. So this just say, okay, removes key release events for held keys. So when we hold like a key down, it would not say key pressed, key release, key press, key release. Instead, it would just keep saying key press, key press, key press. So that's the desired behavior. And then we use X display key codes, and this is going to get the first and last key code. Why is it getting that? Why do I want to do this? X display key codes. X display key codes. What do you do? So you give you the min and max key code. Supported by the is never less than 8, right? That makes sense. And then the max return never greater than 255. So it's just the key range. Okay, fair play. Anyway, we'll figure out why that we need that anyway. So we might be able to remove that. So what we need to do now is we need to find this function, right? This update key map thing, because this gets called in a few places. Because there's an event that can happen where the OS notifies that it's changed the keyboard mapping, and you want to rerun this function that we're going to get here. So this function here goes and prepares all the super lovely lookup tables so we can do the mapping between QWERTY, like that scan code and the key code, basically. So that's what we're about to do next. So we're going to make a new super lovely function, and it's going to be called OS Linux update keyboard map, or keyboard map update. OS Linux keyboard map update. I want to upload as my muscle memory update. So we'll drop to the bottom. We're going to throw this in here, and we're just going to take a little look around here and make sure everything is good. All right, so we'll call that. I don't think we need this here, so we'll see. First, last, interesting, min-max key. Why is it a bit of... All right, we don't need it. We might not need this call. Let's delete it. Right, we'll just grab it back. If something doesn't work, we'll just grab it back and see what happens. So we're going to get the display connection from GOS Linux. Excellent. Now we're going to go over all those super lovely key codes. So let's just do this little find and replace. Oh no, that's wrong. Alright, and we'll correct it now. So we're gonna reset the key codes, the key code to map directly to the scan codes. Yeah, so we're just gonna go over this sort of like scan code to key code map and key code to scan code map, and just make them basically be the same. Just do nothing, right? You send in the same key code or scan code and get back the same key code or scan code number. So what we need to do is we need to ideally have this yeah. So inside our OS Linux thing, backend, we're gonna have a new structure and just call it OS keyboard. And this is gonna house all of the state. So we're gonna have like bit fields in here, we're gonna have lookup tables, all sorts of goodness. So the first one is obviously key code to scan code. So you have OS scan code, and this will be like scan code to key. Wait a minute. Key code to scan code, right? And this will have like OS key code count, right? And then you want to do scan code to key code. So you want to say key code. Okay. And then your yeah. Fish shell, damn straight. Yeah, fish is good. Like, I think there could be many more improvements to shells, but fish is much better on top of, instead of bash. You automatically get the, the hints and everything. Yeah, it's pretty great. I like it. So we're just going to chuck a little keyboard data structure in here. There'll be more things that go in there, I'm sure. So it's got a little lookup table. There we go. So we're going to call this little function here. And it's called get updated map. So I guess... Right. Okay, I guess it updates that map that we was looking at earlier. So GOS Linux. There you go, XKB. Cool. So we call this get state thing for some reason to retrieve this. I have no idea why. Oh, I forgot about this. Okay, interesting. You'll be in for a treat. GOS Linux. Right, we'll get there in a sec. We're just gonna quickly put this in a little thing like that. So we don't map any more keys than the keys in ndev after, or evdev after 236. Right. Good thing to know. Wait, after 236. Entirely depends on the lookup tables though. Do we use lookup table? We do take 8. So is that wrong? Shoot. $205. So the evdev scan code to R scan code. What is that one? evdev. Yeah, 236. But then we took away 8. Yeah, I think that might be a bit of a bug. Yeah, and also I don't know why my lookup table. Yeah, we'll look into that. Right, so basically there's this so we iterate over all of the key codes and we go and get this sim map thing. Yeah, I think the way these things are structured is very weird. You have to like understand how um I completely forgot how it's structured, but I think there's a I think for each key there's a pre-allocated set of 4 elements for some reason next to each other for each key. And I think you have to skip over the group of those anyway, you have to oh, where's the documentation here? Um, group shifts. Um, yeah, there's something going on. I completely forgot. But essentially, you need to skip over the size of that group. Um, I forgot exactly where. It's somewhere on that page. Um, yeah, so we go over all of these. So the EVDev scan codes are 8 less than the X11 scan code. So when we want to use it, translate it to an EVDev one, we just sort of take away 8. And then we can use our lookup tables translated to our proper scan code. And then we can get our key code from it using our translation function. So, right. So you get some sort of symbol map record, I guess. You get the offset into the symbol map table. And then since we do not want any key modifiers, interesting. So I guess you have a group of stuff depending on the key modifiers together, and we just don't want any, so the shift is 0. And then to calculate the symbol index, it is simply this thing where it's the offset plus the width of the times the group plus the shift. Right, so start based on the key code plus this stuff. Gets you your symbol index, and you can use that to get this key sim. And then with the key sim, you can use that to get your key code, basically. Like, what is it in respect to the keyboard layout? And it's not a scan code anymore. But yeah, that's what we want. And we've got some logging stuff here. If logging is enabled, I don't know. Maybe we should. We should really have a proper logging thing at some point. Let's just if 0 this. Not gonna lie. Right, so let's get these couple of lookup tables. This is a function apparently in this code base here that we're in my old code base. But I think it just calls into this. Oh, there's different lookup tables. Right. Okay, we'll sort that one out as well. We'll grab this. Okay, so we'll grab all of our lookup tables in just a sec, and we'll translate it over. So this wants to be, again, and we'll just do one of these. All right. So we're going from a OS keyboard, OS Linux keyboard key sim to key code. We'll take on the X key sims in nowadays. X11 key sim. Let's just make it easier to know it belongs to X11. So So this says they're function keys or something like that. I don't know. We'll look into it. Yeah, we'll get these just in a second. I just want to get... excellent. So basically we're going to have some lookup tables. There'll be like OS, Linux, keyboard, evdev scan code to ask key code map. We'll index into that, get it. Then this will just be a simple GOS Linux key code. Oh yeah, we just, you know, it's worth filling in the proper table for it. All right. Oh, nearly there. Nearly there with the setup. So now, so I've got to remember this still. This is still wrong, purely imagine. So we'll bring in the tables and we'll correct all this up. So let's go get all these super lovely tables. So these basically, you know, they translate the evdev into our scan code or from a key sim to our key code, right? So we'll get these. They'll go like at the top of all this internal-y stuff, right? So kind of like here-ish. Bearing in mind yeah. 8,000 characters, damn straight I do. Programming. So we should probably get a little section header. We'll call it like internal for now. We could probably have just given it like keyboard, not gonna lie, but we'll just call it internal. I don't know. And then that way, I don't know how much of this is there's gonna be, but yeah. But this way it can at least be grouped in a different place. Oh, so let's just do a little bit of a refactor here. Wrong one. That one, and then that one. Excellent. Right, so let's go from the top. Have a quick little look. Right, so this is going to be called something like OS, Linux, evdev, scan code to whatever map. Did we do that before? No, keyboard. Yeah, okay, got it. Gotcha. So that's going to go here, drop it here. There's one. Bear in mind it wants probably an external on there, right? And there you go. Excellent. So I don't think this is fully complete because I think did I remove the calculator? Sleep and app 1, app 2. I think I removed these because I don't think we was ever going to need those, so I just removed them. Yeah, they're gone. So we're just gonna null them out. Like the sleep button. Like, I don't think we ever want to know about that, or the mail. But you know, we can always put them in if we need them again. I guess people could. You know, I think these are more bound to like system applications, so I don't want to get in the way of those system apps. You know, it would be good to put proper comments to represent the environment dev thing here, but oh well, doesn't matter anymore. Display switch, keyboard, loom. Right, all right, we're good. So realistically, right, we don't really need, like the last one we have is cancel, right? So realistically, like, actually just saving the for loop. You know, we did that earlier on the for loop. I don't think we should really bother. We should just let it just iterate over all the way to the end, you know? Mate, this is insane. How long have you been programming for? Mm, about 13 years. Yeah. 13, 14 years, yeah. But yeah, it's just lookup tables, man. That's it. We're just translating operating system stuff into our own abstraction. And rather than going through many layers, we just have one layer. But yeah, it's okay. Like the problem is OS APIs are proper old and crusty, so they can look a bit weird. So this lookup table translates a function key symbol. Wait a minute. Wait a minute. Why did I call it this? There's a reason. Alright, we'll keep it called that. I guess they're all like... Yeah, I guess they're like function keys and all the special keys, right? I guess. So we'll call it like OS Linux keyboard. Use him to key code. Yeah, that will do. So we'll grab this one, chuck it in here as well, extend this. Alright, do the next one. So this one is extended, apparently. So then this one here is Latin 2. Then we don't have eject anyway, so we can just remove that. So let's have Latin 1 then. So it really is like keyboard. Excellent. So we'll take these ones with us. Drop them in there. There we go. Okay, so now, we've got those lookup tables in. Now all we need to do is make sure these are all plugged in right. Bearing in mind, this one, we don't really have one. Okay, so we'll say OS keyboard. Okay. OS Linux FN keysim. Excellent. This one is FN extended. This one is Latin 2, which we don't have Latin 2 anymore. So we'll just comment it out. And then we'll just do return OS key code null. Cool. Yeah. So these are our lookup tables now. That is good. I don't really care about this sort of last key code thing. We should just go to the end. You know, maybe we should go to the end of the array. Well, we should probably say last key code. If that's greater than probably like core array count of this thing, take away 8, right? Then, because we take away 8 to get into it, right? Then we should be set to take away 1. Is that right? So if that is greater than what? Different integers, int and long. Oh my days. Okay. Well, I'll just say like U32, right? Okay. Cool. Right. So that's going to stop us from going out of bounds at least. And this wants to be a U32 as well. Okay. Good. Right. So now we've got our function in. That sets up our keyboard map. Yeah, I'm not sure. I'm not sure what the Windows one looks like. To be fair, hopefully it's not as. Hopefully it's kind of straightforward. We'll see. Right. So we've got this little keyboard map in. So now we probably initialize X11 X keyboard. We probably set up the keyboard map. Should we run this code and just see what happens? Right. We can enable this printing code, and what we can do is we can simply just put a breakpoint somewhere and just see what the terminal says it is, right? So put a nice little breakpoint in. So OS keycode string. Right. I remember. There's like a function, but then like there's like a function. No, there isn't. Okay, it's just a lookup. But so we haven't really done the strings of these. So should we do those? So that would end up just being this. This would just end up being this. And this would just end up being this. Now, my days. GOS Linux keyboard map. Excellent. So, we should really fill in, like we should have a keyboard section now. That's kind of like above this window thing. So we should find where this is. We should plop that in there. We should get the super nice header. And then we should probably, no, we call it keyboard. And then we should probably, yeah, I should probably fill some of this in, well, yeah. So have we got like a string lookup table for this? Keycode strings. See, this is kind of shared though. It's kind of shared between all the different operating systems. This bit. It would kind of be nice if they were like in like a shared area in some kind. Maybe we could have OS common or shared or something like that. Yeah, I think we might do that. Like, you could have an OS common section or just os.c. Yeah, and then we'll have a Linux specific section perhaps. Yeah, so maybe some of this, yeah, but then like, ugh. It's difficult. It could be like the GPU where we have different different backends. I don't know. Because it is generally like you're just creating the same, but it will be compiled out, right? And you could just copy paste it around. But then every single time you add a new thing, you have to make sure it's all duplicated in the right place. It's just, yeah, I think we need a good way to share all this stuff. But anyway, let's just put it in this place for now, and we'll yeah, we'll sort it out. We just want to make sure that the code we've written just works, right? Hey Joe Mega, how you doing? Oh, oh. Alright. Oh, so I think some of these are going to be missing. There we go, all these buggers. We just got rid of these. Okay. All of those as well. Nice. So these ones... Yeah. I think we want some code sharing. That would be good. Alright. All compiles. Right, so we hit the, there we go. So here's our lookup table. So we're basically printing out. Right, so when we map everything, we say scan code maps to this key sim, and then afterwards we do scan code maps to key code. So this is with X11 specific stuff, but then afterwards we do it mapping to a key code. So if we take a look at an example of the T key or something, wherever that is. There you go. So remember when we did T? T maps to G. There you go. So that's the Colmac keyboard layout on the key code and the scan code there. Print pretty meh. Both Dysmorphia and Dysmorphia can't seem to leave me alone. There. Yeah, sounds pretty. Yeah, it's pretty tough. Maybe. Yeah. I'm not sure if I've got anything I can suggest really. But yeah, hope you get sorted out soon. But yeah, how's the job doing though? How's the work? Dysmorphia is the gender one, and dysmorphia. Right. Right. I see. Oh. Right. So we've got the keyboard map, right? So we'll just like turn these off. Okay. But now I want to think about like how do we share common stuff that's like, it is an OS abstraction, but really there is some shared stuff. Like on the GPU side of things, what we do to tackle this problem is we have, let's draw it. We have GPU .h, and then we have the backend. We have Vulkan, right? GPU backend underscore Vulkan. So this is the Vulkan backend, and basically like we call this GPU.h calls into the Vulkan backend. Whereas right now with the OS maybe this was not exactly the way. What I really mean by this is we have the GPU header, which then has a GPU C file, right? Which does some of the shared logic in there, across the back ends, like, you know, makes sure, asserts to make sure the parameters are fine and all of this, and has some shared state in some globals, and then this will eventually call out into the back end for the, you know, Vulkan, for instance, right? Okay, it will call out into that. And then, whereas for us right now, for the OS side of things, it kind of just skips this step and just calls directly into here. So it's like, do we want to emulate this behavior? Or, yeah, I think we might just do that. And sometimes we'll call directly into the back end, because sometimes it's just, there's just no point doing stuff in between. Like doing like OS DLL open, like you just call like directly into the back end for that one, you know? I'm unsure. Anyway, I have a think about it. Hey there, Kappa, how you doing? How's things going? Yeah, so what we have is a way to map keys right now. But I want to tackle this issue of how we're structuring this before we carry on to do actual like keyboard events. And but yeah, we have a way to map from the OS stuff though, which is good. What gender is my kid? Uh here's a male. Yeah, I got a little boy. Yeah, I'm doing good, man. I'm doing good. We had my wife had a what'd she do? She had a baby shower, and I went over there and got drunk, and we got tons of goodies, tons of nappies, tons of clothes. We got like 3 pairs of shoes for the little boy. Um, yeah, it's all really cool. So we're definitely prepared now. But I'm surviving on like 5 hours sleep, like a moron. But yeah, that's me. Um, but yeah, nah, no stress yet. I haven't even got a baby yet. Hey, Majestic, Mac, welcome back. Yeah. Oh, I don't know. Well, take it as it comes. I get a whole month of work to sort of, you know, work the baby out, figure out how to do things. But yeah, it'll be cool. Well, it can say from experience, even if you are assigned male at birth, you never know, although chance might not be that high. I don't know. I don't know. Right. So, what to do next? Right. I might go and get some snacks because feeling a bit peckish. And then when we come back, we'll tackle this problem of like this, how the GPU will go. You know, the GPU does this, which is great, but the OS layer just skips as sort of a shared understanding. Like, so the back end of you know, the OS backend has to keep implementing the same logic, and we want to maybe get some. There's some cases like this lookup table that translates a key code into a string that we just want to share across all the backends. So yeah, we want to sort that one out. Um, right. So yeah. Right, I'll be back in a couple of minutes. Enjoy the tunes. Wait, the tunes are still going. Hmm. There we go. BRB. Alright, welcome back everybody. Got me some mixed nuts, you know? Oh, these will be good. So, right. How are we going to share stuff? So, think about some of these internals. You kind of do have an idea of a window, and it probably have a size on it. Right, and the function that returns the window size could just be shared. So, I'm thinking. Let's look at the GPU. Yeah. Right, it's the back-end structure. There could be like a back-end pointer. So like these are kind of shared, right? Page size, window, and keyboard. So maybe having like a back end, like it's all internal anyway. Something about maybe mostly doing something like source OS internal .h. Then I'm thinking about doing something like, you will have this basically here, right? Now the question is for the backend specific stuff. So OS. So the question is for the OS specific stuff, like how do you put it in here? In GPU land, we do this. We just have an array of data. Bear in mind, this should probably actually be aligned. Align as something like that. Anyway, yeah, this should probably be, we basically cast that back-end data into the thing we need. What's great about this method is you don't need to include the internal header and get exposed to all the garbage in the more public. Well, it's kind of internal still, but the shared layer. Yeah. For my software OS things, I just have an abstraction which also contains an opaque handle. Yeah, I'm not sure what you mean. Yeah, I'm not sure how this solves this problem specifically, but like, because I want to have shared data. But yeah, I might go with this approach. We change the size. But it might be a bit annoying. So you'd say like OS window backend size. But the problem is you have to make a certain size in a certain place. Basically, the OS is only unique data. I have right. I see. Right. So you have a handle that you can get the shared data with, and the same handle can get the OS specific data in a separate place. Yeah, that's another way of doing it. Yeah. I think I'll try this approach out again. So I want to make sure that we have OS Linux window for the Linux specific data. Change the size of. That is Go's approach for platform-independent APIs. Which one? Or the way that we're doing it, or the way that has been suggested in chat by Joe Mega. Yes. I said, oh, I don't know which one still. Yeah. This is my window. Right. And the OS data is something else. Yeah. Yeah, I want to avoid having the data accessible though. Wait. Maybe. Yeah. Yeah, I think I used to do it this way, where you basically just have like a back end thing that you can sort of like get access to. Yeah, I think want to make it a little bit more hidden, but I guess you can still get access to it if you just include this header. But yeah. What? Oh, Core OS Linux. Alright. Gotcha. So we've got to change that number. So 24 is too much. It's probably 4. Alright, this might be 8 then. Okay. Go manages platform name for each package. Only have handles, yeah. Yeah, I think I just prefer to have the all of these includes not included by the rest of the application. I know we're doing single compilation unit right now, but in the future if we didn't, I'd like the idea of this is only getting included into one compilation unit, right? Which would be the OS Linux side of things. So I like that separation. I don't like to give out the raw OS types. They'll be in some form of opaque handle, like a void star or something, right? And that's the sort of plan we'll roll with. So I think we'll have some Linux keyboardy stuff, maybe. Maybe not, actually. Let's get rid of that. But we're going to have a Linux sort of thing. Yes. So when it comes to this, there is just going to be an OS1, and there will be a backend data for it. So we kind of want to do like a line as. I guess we could. You know. Right, that's much better. There we go. You go first opaque interfaces, else it'll be hard on programmers, yeah. Because someone will start using the internals, which is okay sometimes. But like you're just hacking around. But most of the time, like you want to know. Like you want to draw a line. So yeah, like if this header is included anywhere other than OS Linux, it's definitely a problem. I shouldn't commit the code. So this can all go, right? No longer is that anywhere. Alright, let's get rid of that. All gone. Excellent. Gotta change some of the things, but okay. So we're gonna do a line as. So we'll have like some sort of window backend align as well, which is line as 8. Then we'll do another one which would just be OS backend size. So again, I don't. Oh, which one? What is that gonna be? Right. 1 pointer, 2 pointer, 3 pointer, probably 4 pointer. I don't know. So we'll do a line as. We'll call it backend data, and we'll give it a size. So we'll do a U8. Do that, and then we'll say Wait, that's the wrong one, isn't it? Yeah, I think I like sticking these at the bottom, to be honest. And then I want to. This is the window one. Actually, we'll just do a nice little window like that. Okay. So then this is gonna have, you know, GOS just like that, and it's just OS like that. Hopefully that name is not taken, but anyway. Not the end of the world if it is. Then we're just going to have a new file called OSC, which is going to include the OS internal. Then we're just going to drop this thing in here, make it a proper thing. Yeah. So we kind of want to have some functions where we say, right, get me the backend type. So I think we do this in well, no. It'll be in the Linux side of things. On the Linux, you want to be able to get this OS Linux thing quite easily. So we probably just want to say OS Linux void, right? And we can just get this thing for that. And then we probably want the same for OS Linux window, which just takes in an OS window. So we'll get that all sorted out as well. You know, we'll drop it at the top. You know, so let's get in there. Oh, what we're doing. X11 handler. Right, drop it there. So we're just gonna be. Oh my days, I got the thing wrong. Windows. Window. Right, good. So this will just return. Effectively, it's going to return G or casted version into this, right? The address of GOS.backend data, and then this one is going to be window dref backend data. Take the address, cast it into the window. There you go. So we got that there. That'd be handy. So we can use that basically everywhere. And so some of the things are actually going to be implemented in this. Some of the keyboard related stuff. Right, so a bit of a catch up. But yeah, the actual OS implementation is still kind of if-def in my code at the moment. Let's move away with that there. If we had to do that raster, we don't want implementations to be contained. Yep. Now the word rust triggered it. Okay. Right, so now we want to kind of replace GOS Linux dot with OS Linux dref, right? That'd be a good one. You know, some of them would just be like GOS though. Damn it. I guess we can just say gos.window.backend there, because we only have one window right now. Right, so this one would just be window x11. Fantastic. This one, see this get window size. This one can just go in that new lovely, this goes here. The implementation is kind of platform agnostic, right? So it's just gos.window.size, which would be super nice. That'd be cool. So you go to that there now. And then this again would just be, so if we've got any sort of OS Linux window.size, if we've got any of that, this can just be gos.window. There we go, sort that one out, very good. There's also this OS Linux stuff going on. I don't know if I like what I just did. Instead, what I might do is replace OS Linux this with probably something like OS Linux. Yeah, but then it might, so it's a local variable name. Hopefully that should be fine. No, I don't know if it will be. We'll just call it like Linux or something. Or maybe OS. Backend. OS backend. There we go. All right, and then we'll define a local. So in every function we use this, we just define a local called OS Linux. This should just be OS backend equal to OS Linux, like this. And that way we're not doing it everywhere, and it gets, you know, probably not the best code that gets generated. Obviously it gets cleaned up when it gets optimized, but still. Would rather save it the headache of doing that. Right, so just drop it in all of these. I don't know how much of this will actually need it. I don't think a lot of these will. So for instance, when it's like backend page size, so we should probably replace OS backend page size with simply just GOS page size. There we go. So that's cool. So if we've got any more of these backends dotted about. Let's drop that one in there. Boom. Sitting wall dotted about. Obviously all in this guy here. Rightio. This one, you probably want to get the OS window. It's the keyboard map. Some of this stuff though is not out. So if we do anything with like OS backend keyboard, I think we want to replace that with simply OS or GOS keyboard. Ah, yeah. Very nice. Anything else? All right, so that appears to be the end of the function. Right, it's got some linker errors now, no biggie. So it's simply because we don't, you know, within a single compilation unit, we're just simply not compiling that new OS file. So we'll, you know, we'll drop that in there. Okay. So obviously we didn't move over everything. Actually, let's just double check it quick. Right, we still just hit our breakpoint. Right, it still runs, all good. So we're just gonna move over some stuff that we might have simply missed into this more shared thing. Right, we've got window size in there. We need like keyboard, lookup tables and that. But yeah, it's going good. Hey there, not so red. Yeah, man, doing good, doing good. We've now transitioned over to using our custom collections um, everywhere. So all of the allocations are now pump allocated. So yeah, we've got our custom stack thing that we use. We've got like an object pool for the GPU resources now. Um, yeah, no mallocs anymore. Goodbye malloc. No inlined arrays that are unnecessary. Um, So yeah, it's all going super good. So now we're working on the keyboard input stuff. So yeah, it's going good. We just decided to because I'm not sure if you're aware, but in the GPU side of things, we have this sort of GPU interface, and then there's a C implementation of it, right? And then that calls into the backend, and there's some sort of shared code that goes on here. So the problem we just solved, you see, is for the operating system, we didn't do it like this. For the operating system, we had the interface in the header, and we went straight into the back end, and we had no shared code. So now we're not doing exactly like the GPU. We're doing sort of like an in between. Some of the stuff hops over, and some of the stuff goes through some sort of shared place. Or no, maybe it doesn't go through. Sometimes it just goes into here, and yeah, and other times it goes, yeah, so that's all we're doing. Um, yeah, how's things going on, sir? Have you been up to much? Hmm. Talking about input, and go back to my input stuff. Right. Mm-hmm. Yeah, I think I might do the Xbox 360 thing as well. Like, just do an interface of that. But yeah, sounds good. Oh, excellent. x86 assembler. Sweet. Oh, you're doing an x86 assembler, even better. Oh, my days. Hardcore. I like it. The 360 has an annoying feature that triggers are both the same axis. So the one -1 and the other. Oh, so they're not on the same axis, right? Oh no, they're on the same. Oh, right. Pressing both results in 0, really? I did not know that. Hey there, Louis, Luisha, Lishik, I don't know. Lishik, that's the name. What color scheme is this? It's kind of based on some other color scheme that was just yellow and kind of had this background, but I've added a red and dotted it all in. It's kind of custom. I posted it to someone on my Discord before. But yeah, maybe I should just make a gist and just so I can just type theme in. You know what I mean? When there just be, yeah, kind of custom. Should we do that? It'll be a bit of fun. Um, so it'd be home. Right. Basically, that's it. Yes. Do a little this. How does one do a gist? Bum ba bum ba bum bum ba bum ba bum bum ba boom. Do a new gesture. My gests. Let's do it. Do 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 do. Red, yellow, Vim, theme. It's a secret. Enjoy. We should do a command for that. What bot am I using? Fossil bot, that's it. Let's do it. Let's add a new thing. Do 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 do. So the command is going to be a theme. Response, this guy. Save. Enjoy. There we go. Why not just Grovbox? I used to use Grovbox, but again, it's not like 2 colors. It's like 50 colors. It just started looking ugly after a while. It looked really cool though when I used to like it. A bit like Dracula. I used to like Dracula so much, you know? Yeah. You start getting bored, you know? Wait, my phone is disconnecting. Oh, it's back. Okay, it's good. All right, let's go. So, things. What's the next sort of thing we're doing? So yeah, we just want to make sure we got some of the shared stuff in here. So, really, all that keyboardy stuff, that keyboard section, really all of this, I think, should just be able to go in this shared section. So the layer, window, keyboard, good. So really, like so knowing whether something is pressed or has been pressed or this is actually going to be stored inside of this keyboard data structure, and it'll be a bit set. So it's just shared across all the OSs, but we'll get there in a bit. So now we're back to where we are. Shall we advance to the next step? So the next step is called processing events. Bum, 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 bum. And this is where the magic... Yeah, this is where the magic happens. You know what? Let's get the bit sets in. Let's do it. So we need some bit sets. So what you need to do is pretty simple. You got a key code. It's a compile time constant. So we can do our bit set thing, and it's going to be do we need like a scan code is pressed bit set. So for this one, you need a sort of like a divided round up again, a rounded up divide from this by 64, right? And you do the same thing, and then rather than is pressed, it's has been pressed, and then rather than has been pressed, it has been released. And then you obviously want to repeat that and dupe it for key code. Wait a minute. Is that right? Is that right? So key code can translate into do we need one? Scan code can translate to key code. So whenever you do scan code, so to save memory, you could do a lookup. Yeah, no, that's great. That's just waste of memory. Right, there we go. So let's have these tables. So basically, in the OS side of things, pretty simple. We just do like return core bit set is set, and we do this whole sort of like gos.keyboard dot scan code is pressed bit set, and we're looking for the scan code, you know, the bits at, because it's just an enumeration, right? Can I get that bit index and know where it's set or not? Thank you very much. Has been pressed, has been released. So these are useful because, like, if your game's running really slow for some reason, or whatever the reason is, yeah. Like, sometimes you want to know, has it been pressed this frame? Has it been pressed this frame, but not the frame before? You know, so is pressed just knows where it's been held down or not. Has been pressed means did you press it this frame? It has been released. Has it been released this frame? So these are pretty handy. Right. I'm very happy with things. I was looking around and I found this Visual Studio theme called. Oh, that's funny. Because I remember Rohan just literally mentioned that earlier. It's interesting you found the same thing. Low level is the way, my friend. The answer is quite possibly yes, Joe Mega, because, you know, if you just look at Vulkan funny, it will like fall over in Korea. Just... Oh, we need a light on soon. Okay. So key code to scan code, that's just those lookup tables that we got, right? Return GOS keyboard. So this one is obviously key code to scan code. So you just do the lookup. And then scan code to key code. And then scan code. Oh, right. So there's the nice little shared functions. So now what we need to do is we need to populate these bit sets, right? So part of when we process the OS events, we're gonna populate these guys, and we also need to make sure they get cleared as well each frame. So they need to get cleared, or these need to get cleared each frame, but these has been ones need to get cleared, and we need to keep them updated. So, right, wait a minute, did we get everything? Wait, let's quickly double check. So read all, like, that should be unique for every platform. Backend, that's unique. Yep, I think we're good. Yep. Okay, I'm happy where we are. So the next thing to do is process some events. So we're going to go into the, here's one I made earlier, and we're going to, when we process that event, so first of all, let's look at when we've sort of done that key map thing. Let's quickly get this one in because, you know, it's very easy to. So there's a map notify. I think we got to subscribe to this event, but this is just a little bit related to what was done earlier. So in OS Linux, we can go to the. If you remember before when we set this thing up, it was the iterate over the events, right? It's the event iterate next. So this just does an X pending, checks whether there's any event And if there is, we'll actually get the next event. The reason why we don't call next event is because next event will block if there's no event. So you have to call xPending if you don't want to block. Notice if there's a key press or key release, this is what we'll be looking at in a second. But we want to do another one quickly. And that is if type is equal to key map notify. Bear in mind, we probably have to actually set something special. What is going on? Oh, it's a dot. Cool, and then this one is, I forgot what it is now. That one. So all this is doing is like, oh, the user changed their keyboard layout, refresh our lookup tables. That's all we're doing. So that's the function we made earlier. Awesome. So the next thing we want to do is, oh yeah, we need to make sure we subscribe to this event. So when you create the window, we need to make sure that we subscribe to the events, this one. So we're gonna find, oh, sorry about that. Let's close these. We're done with that. Select input, right? So these are the subscriptions we got. So we need, is that, where's the XKB one? Is there one? I guess there's no, okay, I guess it automatically comes through. We'll have to try that. I don't know. I'll look at that. Give me a sec. X11 map notify. XKB select events. Oh my days. I need this one. I don't know why I'm using Kate Perry. All events. All the events. Is that a good idea? D for display. Yeah, so we missed this. This is not good. Yeah, so we need to, but all events mask, that's not a good idea. So we want to map notify. That's the one we want, map notify. Okay, that was actually easy to find. Usually with X11, you're just like, honestly, it's so bad. Why did they do it twice? That is the question. So we're going to look into what this is. Bits to change, values for bits. Clearly understandable. Determines events to be selected, deselected. One selected. Right, so the ones you want to change and what you want to change them to. Okay. Right, so what we want is we want to change. So you just put, okay, you just put the same ones in basically. Hey there, Nico. How you doing? Gonna say once again, pipelines were a mistake. Nah, they're not. They're fine. First, gonna write some natviz debug, decode my bit packing. Yeah. I'm not sure if we have like a natviz equivalent on in GDB. Maybe we do. Oh, it's so bloody warm. Just melting along. Yep. Isn't it pretty print something there? I'm not sure. I have no idea. Right, so that'll be decent. Let's get that notify mask. Right, so now the next thing we want to achieve is what do I want to get? Yeah, you know what? Yeah, I want to listen to Perry. Perry's a sensible person. Just open it up in Vim, man. Yeah. So this is my old abstraction layer. So, like when you do key press. So key press, key release. So remove the control modifier, causes control codes to be, as it causes control codes to be returned. Interesting. So yeah, things can be shifted up by the control mask. Yeah, I want to avoid that. Right. So let's get this one in. So key press. So we currently have a key press in there. Key press, key release mask. Okay, interesting. Key release mask. Good. So the issue Good. So the current way it's implemented, right, it's not the best, but we threw something in just to sort of like, so I copied it from like one of my sample projects in HCC, and we just used a char key to represent, we just translated it into a char key, which is not, it's not good obviously, but now we've got a proper one. So we're going to be changing that out into a proper thing. So we can do like so for instance, like if you go to the event in here, we'll be doing a key like this. So I guess we'll get rid of some of these. So we'll say OS. Right, we'll get rid of the key mod for now, but that'll come back. So that'll tell us what modifiers are pressed, like is it the control key that's pressed or the shift key? But we'll do that in a second. Let's just get these ones in first. So is it pressed in and has it been repeated? Or is this a repeat? Kind of handy. Right, so what we're trying to do here is xc_deref xc dot. What's okay, so this can all get deleted under here. Right, so remember when I was saying you got this sort of IM thing? Oh, is it IM? Oh, maybe it's XIC. Maybe I got it wrong. But yeah, it's the way to sort of like get X11 to automatically turn it into a nice string for you when you press the key. So it'd be really good for like text box input. Yeah, we'll go look into that. What's the difference between expose and configure notify event? Which one is one used for resizing? So configure notify is for moving and resizing, but you have to manually figure out which one it is by figuring out if the size changed or if it whatever changed. So yeah, you got to figure out some stuff. We haven't got window move yet, so we're just doing resize for now. Yeah. So you have GDB pretty print, which seems to be done via Python script. Oh. Fair enough, I might take a look at that. No worries, no worries, what's up? Right. So this XIC, maybe the XIM is used with XIC, I forgot. So we should really get that XIC thing in as well. So in the window, XIC. Yep. So we want this. And again, we're going to call it like X11. I see. Maybe XIC is fine. Screw it. So we need to actually instantiate that. What are we, 16 bytes now? We can't be. Oh, we are. Okay. Cool. So we need to actually instantiate that. So XIC. Right, create an input context for the whole window. You're supposed to have one of these per text field, but this should do. Excellent. That's what I like to see. So I need to do that when we create this window. So it's our window open or whatever it is. We want to put that there. Probably flush it at the end. Oh yes, it does take the XIM thing that we saw earlier. Right, so I was right. The XIM thing is the same, but the XIC is some context per window. Okay. Oh my days. OS backend. OS window backend. X window, let's call it WW. Oh my days, no, that's just the OS one, isn't it? Excellent. Right, so we create one of these things when we open up a window. Obviously you need to destroy it if you destroy the window, but yeah. We set the focus on it and then we just store it in here. So when we process events or something, so get the window at least. Yeah, we only have one window that we care about, so we're just gonna say we'll just plop that up there. So this here is OS window backend. Okay, so do not send any keys like Control Shift function, arrow, escape, return, or backspace. Instead, send regular key events. So this is something where we say, hey, queue up an event for us, which is basically just some character as a string, right? We do kind of need an event queue now. We don't really have an event queue, so let's go and get one of those. Because right now we just return the event right away, and technically these X events, because they're so wide, they do many things. Technically they can return more than one event, so we want a way to sort of like cache the event on a queue of some kind, and then give you the head of the queue. So that's what we're going to do now. So in the internals, we're just going to have a super lovely event queue. So we're just going to say core stack OS event, and this is the event queue. And you might be like, well, why don't you use a queue? Why are you using a stack? Well, the point is you'll go over the whole queue. So you have like event queue, read index or whatever, or cursor, whatever it is. When you've exhausted the stack, we'll just clear it, and when you clear it, you then start looking for more events, right? And if that fails, you've finished. So you don't really need a queue. You can get away without a queue just fine. Oh, hey there. Wait, where do all these people come from? Welcome. How you doing? Fafaligo? Yeah, welcome back. Yeah, X11 window handling, the pinnacle of engineering. Yeah, no, right. Like, this is, clearly we haven't evolved since the X11 protocol was made. Like, programming has just gone way done. I'm joking. Yeah, the X11, oh my days. It's very strange. You very much have to sort of, it's very hard just to figure out what's the right thing to do sometimes. Now the question is, what's the chance I don't screw up NatViz? Visually, can hot reload it. Rust has baked in the debug file. Huh. Yeah. Another reason to come back to C++. What's your advice on becoming a better engineer? Yeah, practice. Speak with other people, get different opinions about things, right? And do different things, try different things, even if you think it's wrong, give it a go, get perspective. Yeah, like, and do lots of little small projects that you can throw away quickly, and just learn from them. Hey there, very much. How you doing? Hey, PW Blue Sky. Just curious, Mr. Hiradev, do you find explaining your thought process aloud makes you more thorough? Yeah, sometimes I capture things I wouldn't have caught if I just programmed by myself. Um, there are pros and cons to streaming. I think some of the pros though are definitely very beneficial. Like, as you're saying, you explain your thought process out loud, and it allows you to capture things, because I have to explain it to people who are, just swinging by, and they might not want to ask a question in the chat, and sometimes it's just easier just to repeat myself. And then in the process of doing that, it just sometimes helps me catch issues, or yeah. So yeah, it's good. Are you using X input 2 or the old thing, by the way? I'm using XKB. I don't know what X input 2 is. I'm using XKB. Is this for touch handling? Oh, X input, was that the thing that they did? Oh my days. Because there's lib input, is that lib input? Is that right? That they did recently? Or is it different? I don't know. Oh, for mouse handling, I don't know. Yeah, I just used the standard one for mouse. I didn't use any extensions for mouse when I've done it in the past. Or maybe I did. I have no idea. Oh, X11. Oh, it works below X11, fair play. Okay. Just wondering how I've developed. Of course, I think everyone is programmed for a bit comes across that fact, but I was wondering how you've developed thought process. I'm not sure if I get the question. Fair play. Fair play. Ransel. Could have been Ransel. Probably just my mumble. Can interpret anything, you know. I'm currently tinkering replacing Jai's input module with X input. It's an experience, yes. Main motivation is probably to handle touchpads and mouse scrolls. Yeah, I think you can do it without X input too. I don't understand what this extension does. You know, I'll have to sort of figure it out. But maybe it gives you more doohickeys. You know, more thingy-majigs. I have no idea. Because built-in XLF generates 10,500 synthetic button clicks when you swipe the pad. Oh, maybe not. No, is it really? All right, I'll have a think. Well, maybe we'll do this one then. Right, so this is another reason why I stream. We get to figure out people's views on things. Yeah, I'll look into it. I'll look into it. Verse. Excellent. I don't know. Developer's guide. Okay, Ximba 2. Bum 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 bum. Right. In the core X11 protocol, the most significant distinction between input devices is the number of buttons they have. The input model quickly became too limited to support the wide array of input devices the users would attach to the X server. A variety of extensions were proposed to fill in the gap. The one that won became standardized in the 1990s was X input, which provided a variety of input devices and input types. X input stayed static for about 15 years when the growth of laptops and mobile devices demanded even more changes. X11.2 was developed. Blah blah blah. Yeah, I could have just skipped that. But anyway, as the rise in the last version of 2.2, multi-touch support. Clients can run, for example, distinguish between one finger, two finger, multi-touch. Right, so you can get like all these swipe animations and that, I guess, if you want that. Is it good? I just want to scroll and mouse clicks, but maybe it's fine. I don't know. But yeah, I should read some of this. Right. Let's do a thing. So basically, basically, we need to define ourselves a new core stack. So we've got our event here, core stack, core define stack, and we're defining an OS event. And simply we're just gonna up that, bam. Got ourselves a new data type for our array. Now we need to initialize this guy, right? So how many events? So when we do our core, oh my days, it's kind of shared now. Kind of shared. So really, OS backend initialize. We need one of these. And this is what Linux is going to implement. And then we are going to implement this in, there we go. It's actually going to call OS backend, but then first we're going to get our super lovely allocator, which is going to be our static allocator. Core, no, game TLS static allocator. So we get our, and then we can do our stack initialize, and we're going to instantiate the gos.event queue with our static allocator, and we're going to allocate so many elements. Now, this is an event queue. Let's just have a constant. Maybe does it need to be a stack really? I guess. So I guess we'll just define something up here, where we just say like I don't know, OS event queue capacity. Let's just say there's 256 of them for some reason. Maybe we'll need more. Let's do 1024. I don't know. We just want to be safe that the OS doesn't sort of just jam tons of crap in there and then it'll crash the program. Maybe we'll just silently avoid the event in that case. Right? We've got to think about that. Right. So, what? Right, it needs the game header. All right, we're in. So, all right, so we got that initialized now. So we need a way now to add to this event queue. Okay, so really in part of the OS internals, we want a way to sort of like just push on a new event easily, even though we're fair play, yeah. Use the C's. Right, so we'll just make it a bit easier. Right, so we're just gonna, it's gonna do one of those pushes, right? Push, and it's just gonna set one of the fields for us, So we'll just say e-type equal type, and then just return the e like that. Okay, so so one thing that we want to achieve is so let's go back to this OS header here. When you like ask for an event, you say it's a next, right? I think we kind of want like a back end one, and I think we're like a back end we probably want to call it like gather events or poll events, right? So yeah, I think with this one, you know what, it really doesn't have to be that big. I just realized we can just make it like 64 or 32. Because we'll just, yeah, this is going to be really, really good. So where is it? This one. Right. So go to where this is. Excellent. So underneath this one, this is where we're going to pull some of the events. So where that iterate next is, we're basically going to take this. And then this function is going to become like a public one. So it's a next. This is going to come with us. And we're going to go like where the window, so window, yep. So we're going to do, we'll figure out this API, wait, how are we going to call this? Yes, I think we'll say if GOS dot event queue dot count, something like that. Maybe we'll say like call stack count, to be honest, something like that. Anyway, so we'll say if this has, if it doesn't have anything, what we're going to do is call that OS backend poll events, right? And then after that, we're going to I don't know, because so if it has something in it and the read cursor is so maybe you just want to say, well, if the read cursor is at the end, core stack clear. So I think maybe what we're saying is like if GOS dot event queue cursor is less than or greater than or equal to count, then we've reached the end of the of reading what's currently in there. So we're just going to clear the whole thing, set it back to 0, pull some more events, and then begin again. So now what we need to do is say, well, if this doesn't have anything, well, so after you've done the poll, no, so maybe at this point you just want to probably just say like, you know, I'm going to probably advance the cursor. So we'll return true, and then we'll say like, you know, get wherever the cursor is on this one, get, and then see, you're returning like you're writing out the whole thing. I think we'll give you a pointer to it. So we'll just say dref eout. So you might as well give you back a pointer, and rather than give you a boolean, just say os event pointer. Yeah, make it a super lovely void. We like these guys. Much better. And then you just return. Now this should probably just be const, right? Really thinking about it. Kind of want to be correct there. But it doesn't matter if you change it because it just goes over it. No, it doesn't matter if they change it. They can change it if they want. Then we're going to return E. Bam. So the problem is here, right? So if this is equal to 0 still, then, you know, oh well. So just return false. But then next time they call the next frame, they'll try again. So this is the basic idea of this guy. Add in IO Uring if possible, because it would be Adventure Pro Max. Oh no. I've not actually, I've seen the API, but I've never tried to implement it. So it's like, it's callback based, isn't it? Wait, you can select to use all the backends? Right. Oh, yeah. So now we do this poll events, and this is just going to populate the buffer as much as possible, and it'll just kind of fill it up in a way. You know, to be honest, we don't really need a stack, but we've done it now. So, what is the plan? So when we do this poll events, all we're doing is we're saying while, you know, okay, if, like, we do this while pending thing, right? And what we're going to say is like, well, if gos.eventQ, so we say like, call stack count, right? If that is equal to the capacity, right? Meaning like we've filled the bugger up, and it would just crash the program, which return, right? And then we'll process them, and then we'll go back around again when we've emptied our stack again, and we'll just read more events off. If not, we get the next event, and then this is where the fun begins. So, back to where we were here. So this one is to do with like, you've pressed a key and you're turning it into something that goes into a text field. So you're queuing at some form of like UTF-8 or UTF-32 thing. Wait a minute. Is it UTF-32? I thought it was UTF-8. It's UTF-8. Why did I say 32? Right, that's weird. Yeah, we need to change that. Anyway, so we're going to go fish out this implementation of this guy. And then we'll write our own. So basically, so keyboard key change. Right, so what's the next one we also need? Keyboard key change. Right, so we'll get both of those guys. We'll bring them over. So the reason why we've got them in these functions is because I think they could be called in different places sometimes. So it's just easier just to say like queue an event. Right, let's take these guys with us. We'll go over what they do in just a sec. So kind of in here, we'll need like a queue event type of thing. But yeah, so we'll find where that one is. Here we go, drop it in there. So we'll replace all that window abstraction layer stuff with right, one more time. Excellent. Radio. Oh, so we called it like push. We could have just called it Q. Could have called it Q. Q's a better name. So you're saying push. Let's say Q. So we'll just sort that one out as well. It's an internal function. So we'll use that here and everything. So this is saying Q keyboard event. Now really, this should just be like OS Linux event, right? Because it's kind of specific to this one. Wait, is it? No, these are shared across the operating systems. This is why I've done it. Right, so the operating systems... Okay, right. Figured out what this is for now. Okay. This is shared across the OSs, which means you don't have to write this code in each different backend. You can just write it in, and it's shared in this file, and we can just access it. You use the same one in Windows as we do in Linux, so it's super sweet. Cool. All right. So we need to remove this. window ID thing. If the keyboard is not focused, don't track the event. Okay. Goodbye to you. Wait, did they make one called... Really? Take a look at that one. Oh, come on, Google. Talos Dark. Does it really? Who's it made? It's made by Sea Lion. Well, it's JetBrains, right? But yeah. Have you got a link to that at all, Ryan? If you can find it. Yeah, I've heard about that Tunodillo. They spill it, which is like classic. Like it's really bad. Like, cause how do you know? You know, they don't tell you how to. You know, you have to do a bunch of performance stuff, right? Seems pretty bad. No, it's tailored for Sea Lion. The original one is still what you got on Google. Right, okay. So the one on Google, is this the one? I don't know, it's not so similar. Maybe looking at something different. Yeah, but it definitely varies, Joe Mega. Like if you target mobile platforms, it's like good luck finding that one out. You know, you be a pain in the butt. All my days. Oh yeah, I wanted to add this, didn't I? Like the raw bytes. Do you need like 5? No, just 4. Right, okay, so we're doing like a... And then a size. Bytes, then a size. Okay, so strut key UTF-8, something like that, right? I don't know. So you have like char bytes 4, and then like a uint 32 size, something like that. Text input. So we use that whenever we have like a keyboard input, basically on a text field. We'll use this guy. These kind of want to do, rather than OS debug assert, they want to do like a core one. Right, it's just a bit of a rename error. So in terms of here, let's drop that in there. Keyboard text input, blah blah blah. Let's call it text input UTF-8. Excellent. So text input UTF-8 will fill that one in. Q will pass in the type there. No window. Mem copy. Excellent. And then excellent. Sweet. No mem copy. What? Include a standard. Oh, it's a string, isn't it? Cool. Nearly there. So this one is about the key changed. So if the key was to change, you would want to, yes, is this the focused thing? We'll remove that. Yeah, we might need to track that, like if the window's focused or not, but we'll see. So this one tells you whether or not it's been is repeated. Platform system must only send out repeated key presses, not any repeated key releases. In OS, in Linux, we call blah to disable blah blah blah. This allows us to simply check if we repeat, but it's been already pressed or not. Cool. So this key mod stuff, we'll do this next time. We get a chance, right? Key mod stuff soon. So this one is, yeah, again, more key mod stuff. Get that in there in a bit. I think we'll write it out though. So if the key has been pressed, we need to make sure the is pressed thing is set to true. Has been pressed is also set as well. Yeah, this sort of stuff, right? So, so this will be like GOS. And then we want to use our core bit set, unset, and all of that lot, right? Excellent. So this does some unsets and some sets there. Yeah, so we just excellent. We need to make sure these get cleared though. So I don't know how we're gonna do it. Need to figure that one out. Key up, key down. Oh, come on. Right, key pressed, released. That's what we're doing. Pressed, and then released. Cool. Yeah, so now we've got these nice functions we can call in our backend when we do the event processing and just pop them on the queue and we can read them off the queue. So look for poll events. So now we should have these guys. So we should be able to say, oh. Let's delete that and delete that. We'll put these in the internals. OS internals, drop them in there like that. So it'll be viewable from here now. Oh yeah. So this released can now go. So I've got a window closed event. But I do feel like if you was to hit something like 128 push constants, why not use inline uniform buffer? Well, because then you have to use a binding model. You might be using fully bindless, but also I guess like yeah, like you might as well store that data in a buffer somewhere. Yeah, it's and fetch it out, isn't it? But I guess you can have a really complex shader with tons of input you want to pass in. But yeah, that's weird. Right, so these window closed and that. So now we've got to transition these over to something sensible. So, do we have a closed one? Yeah, we do have these and like closed and close requested. Yeah, there's like a closed and a close requested. What is that about? Destroy notify. And then I've got... Right, interesting. Yeah, because that's requesting to close, and then you can actually say close. Ah. Yeah, we should... Right, we'll bring that close requested in. There's also a window resize as well, bring that one in too. Oh, we ain't got a window move. I don't know if we'll need that. So we just won't do it. But yeah, we need it, we can always put it in. So I think we'll just drop these guys down here. Again, we'll do this little dance. So we don't need the window. So resize dot whatever. Okay, relative sizing. That's interesting. So we'll do like resized, width, height, and then maybe like relative. So you do signed versions, right? So that's interesting. I call it window resized. And then what else? What else do we want to do? So, oh my days, Benny Montana. Alright, see you later, Joe Mega. Thank you so much for the resubscribe. 20 months. Wow, look at that. Incredible. Yeah. How you been? How you been? Ooh, yeah, it's been a little while. I've been doing good. Yeah, quite tired because I only got 5 hours sleep last night, but yeah, doing good. Doing good. OS window. I've already got it. I've already got it. It's just GOS.window because I only have one window in this thing. Size.x, size.y. Oh yeah. And then size.x, size.y. So we keep track. Yep. Yeah, so you could have multiple events in the same frame, for instance, and you see it change over time maybe. Yeah, you can see each individual change or something. I don't know, it's weird. So really weird to have a close requested. That's a good way of saying it. I'm glad Pass Me did that. So it's like window close requested because you're just saying, hey, you've pressed the close button. How do you want to handle that? And typically you'll just exit, but or close request. The event type is a close request, but it's all like key press is key pressed. So yeah, so maybe let's do it that way. Then we're gonna no window ID. Here's a window ID. We'll do that. Core unused. Sweet. We'll put void in there, and we'll put these in the super nice header, and then we can use those in the Linux backend. So this is going to be OS event queue close requested. This one is going to be resized. Then we put in width and height. Then we get rid of all that. What else? App notify, that's fine. Right, we're looking good, we're looking good. So, right. It's conceptually the same as our scan code. They both used to represent a physical key map. Right. So we just want to map it. So it's like OS, Linux, and evdev. Oh my days. This one. Okay. So this should do all the polling. Let's get rid of that. Oh yeah. There's no break anymore. What? That break is dangerous. We'll say X11 Atom as well, just to make sure. How's the game coming along? Yeah, it's doing good. Obviously no game for a long while. The thing is that we're working on. We've just got the custom memory stuff all in. Got custom dynamic arrays, object pool, hash table. We've done a little bit of test code. We're simply just what are we doing? We just moved on to keyboard input. So we've got our keyboard maps sorted out, so we can use different keyboard layouts and just have scan codes come back and sort of be able to present a nice string to the user still that respects their keyboard layout, you know. So we're just plugging in the event system now, basically, so they can press keys and we'll get back our nice little scan code or key code. So really cool. But yeah, we're gonna be doing this, like getting it all ready so we can prototype with, and then all ready for prototyping with. Do gamepad support as well? Yeah, or maybe one of these, PS4 or PS5, whatever one, right? Get these in. And then do a port to Windows for this stuff as well. I've got to figure out all of that because I've never done that before, so it'd be interesting. But yeah, it's going good. So if we press F5, what happens? Okay, so now this event is actually a pointer, and really you can just say event equal like that now. So it's a lot nicer in that regard. We've got like key presses, and now they're kind of like a scan code thing. So really, close requested, something like that. There we go. So we can turn this into a string, right? You can just say like OS scan code string or something like that. Keyboard strings, and you can say scan code. Wait, key. So we should be able to see that. Press down on the keyboard, which would be really cool. Right, should take that for a spin. Bear in mind, we are printing tons of garbage out due to the render frame stuff. So maybe we can like comment that out and it won't do anything. Oh. Out of memory, my favorite. Okay. Do we really allocate 8 megabytes of memory? Like, what are we doing? Is it not initialized yet? You know what I mean? Know what I mean? Know what I mean? Yes. So this needs, oh my days. Because we need the page size before we can use the, oh my days. It's rocket science, people. So the problem is that when we instantiate the back end, that's going to get us the page size for the system. And the page size is used to create the allocator. So, abstraction, people. So really, like, we need this to be like the first thing that happens. Get the page size and just store it in a global. It's kind of hard. Because you've already called this OS like initialize. So you want to like store the global. Maybe we just do it manually at boot, but that'd be weird. And these things, abstraction is bad. So we could like store it in a global manually, and then initialize this thread local storage of temporary allocator stuff. Right. So bad. Equally, the page size could go elsewhere. It could be outside the OS system. You just call into the OS and say, give me the page size, and you store it in some other place. You could do like we could also do like a lazy initialized version of it, where if it's not set yet, but then like every time we use it, we can't just use the global. It's really annoying. Oh wait, there's this. Do we use this all the time? No, we don't. We use this. Because when we use our virtual memory, we use it. Why are things so difficult? Page size. So we'll do page size. What should we do? Right. Okay, I got an answer. It's my finest work. There's a pre-initialize function. You know. Void OS pre-initialize. You know, my finest work. Alright, so we went places with this. There's a bit of a seg fault though. UTF-8 lookup string, interesting. What? Why did it crash? It would be interesting to like put a breakpoint here and just analyze what's going on. Why did it render a frame? I thought I disabled render frame. Oh no, I left it in for a second, didn't I? For some reason. Anyway. Excellent. So hop in there. So does it crash here? Right, it dies right there. Okay. So we'll restart it. So the key sim. X key. Size of string. You need to get the key sim back out. Is the OS window backend initialized? Anything? It's a null. There's a null pointer. Right. So the XIC thing's not set for some reason. Well, that's probably because we didn't actually create the window by the time. What? We must have done, right? Must have done. XIC. XIC. Should we put breakpoint in here? Oh, so apparently we do go through here. And it's null. Ta-da! So what's the XIM? OS backend. Null as well. So the XIM is null. XIM. Right. Should we go through OS backend initialize? Oh, come on. What are we looking for? So I said something. Oh, I didn't set it. Right. I simply just didn't do this, right? OS backend XIM equal XIM. Oh my days. Okay, progress. Right, so we hit that trap again. We'll remove it and it should work. There we go. So now I want to just quickly remove that render frame. So we put a bunch of like printf stuff in there. I just want to see a black screen for now. So here I'm going to be pressing stuff. And you see we get some unhandled events. But we are pressing, these are the scan codes we're pressing, right? QWERTY, there you go. So if I press it outside, it doesn't show up. That's good. Press the enter key, space key, backspace, delete. There we go. So we're getting some key codes in there, which is pretty good. There are some unhandled events though. I think that's wrong. Where's the polls? Right. Should be in the else clause here. And then be unhandled. Right. Okay. So there we go. Oh yeah. So we can also take the keyboard input for a spin as well. So yeah, you want like a scan code key code, scan code, key code. Oh my days. Scan code, key code. Key code. Oh, what, we don't have key codes in there? I guess the idea is like, if you want the key code, you can just do it yourself. Oh, this is called code. Key.code. Key.keycode, I guess. Key.keycode. Right, let's correct that. Good, good, good. Okay, so we've got those two things there. We've also got this key, wait a minute, text input. So we'll also say we've got some input, text input, and we'll do a nice little dot star s of that, and that'll be event deref this size event text input bytes, right? Like that. So yeah, you see as I'm pressing it. So if I press my let's press the Y key on my keyboard. So the Y key on my keyboard gives us text input Y. We've got, it's the O key on standard QWERTY, but it's the Y key on my key code, right? But if I was to do capital Y, you see it's got a capital Y there. I think I can do alt keys and get some different things to show up if I was to. There we go. Look, I got like the German. I forgot what that's called now. Where it's just the two S's basically. But yeah, you can get stuff like that to show up. There you go. So that's cool. So yeah, at least that can go to text fields when we get text fields. Awesome. So yeah, we made pretty decent progress. We still got to get key modifiers so we can distinctively tell what is the current state of a key modifier, like a control key or a shift key. We also, what else do we need? We also need the mouse support. And then we also need, so after that, it's then gamepad support, something like that. The mouse support, key modifier support, and then gamepad support. So we'll see how far we get with that next stream. But yeah, there's like mouse move, mouse buttons, mouse wheel. We'll definitely need all of those. What other ones do we need? Not keyboard focus. Right, pretty decent. So I'm just going to quickly shoot that up to the, let's get that compiling. Right, we're back in business again. There we go. So git status. So we've done a big change now. I don't know what we want to, what do we do? Yes, we sort of, I guess it's like, begin, add keyboard, add key events, add OS, key events, key press and release events, and I guess that's it. Okay. Wait a minute, I need to do that silly dance. So I want to do one of those git tags as well. So if people want to follow it back, they can follow it back. So git tag. Wait, what are we on? What day are we on today? Wait, did we up that day? Oh my days, did I up the day? We did. Oh yeah. Day 14. Push origin tags. Bam. Awesome. Yeah, so for those of you who have access to the code, you can go and download it, have a play. Bearing in mind this is not on Windows yet. Day 15 will be another day on Linux. day 16 again, and probably another day on Linux to get it tidied up probably. And then after that, do a Windows port. We just want to make sure the interface is all good for full-on input, and we can basically wire up whatever we want when we do our R&D, right? Oh, you found the theme. Awesome. Let's take a look. You got like a background on this as well, fair play. Yeah, it's sort of similar, isn't it, with some of the red and the yellow. Yeah, it's got more things. But yeah, it's interesting. In more colors. I can see the resemblance in a way. But yeah, mine's more just basic. But yeah, fair play. I love it. There's like a whole background in here as well. Cool. What sort of project you working on there, Rohan? Working on a compiler? Is it like a Python? Is this the Python code base? Right. Yeah. So, you know, let's. You know, you guys are welcome to join the Discord and chat. What else? There's a VOD channel. This will be uploaded right there. I will next be on Tuesday, 6:30 p.m. GMT +1, and same time on Thursday, and hopefully next Sunday. I was just browsing the CPython because of PEP 703. Okay, fair enough. Oh, come on, no one's available. Let's find someone to read. It's Ray TCAP. Yeah, good. No, not so red. Good to see you. See you all in a future stream. Well, yeah. Get some nice keyboard input and gamepad as well. I've never done gamepad without SDL, so this is going to be interesting. I've never done it. Be fun. But yeah, have a good start to your week, everyone. Thank you, and see you soon. Bye bye.